So good morning and welcome back to the second day of the Global TBO Symposium. I'm very pleased to see we have another full room here in Europa, and welcome also to all our online participants. We have a very full day today, and to start off, we have some welcoming remarks from Maria Grazia Lapiscopia, who is the Executive Director of the SESAR Deployment Manager. Maria Grazia.
Thank you, David, and good morning and welcome all to the second day of the Global Symposium on Trajectory-Based Operation. It's a pleasure to see so many people in the room and many more connected all over the world. Well, for those connected all over the world, I hope the weather is better than in Brussels. Here is more November than June, but okay. So yesterday we had very interesting discussions on the importance of TBO and how it can contribute to mitigate some of the current challenges, like growing traffic, but also congestion and delays due to lack of capacity. And of course, the natural follow-up that is the excess of fuel burn and CO2 emissions. We also discussed about the benefits of TBO from increased airspace capacity, predictability of operations, scalability, and the important direct saving of fuel and CO2 emission. That is what we all need for our planet. We mentioned the importance of the enablers like ADS-C PP, FFIs, and SWIM, and their relevance in a roadmap. Well, not everybody was agreeing on the roadmap, but a roadmap that can consider regulatory and standardization steps together with deployment milestones towards the full operations. Among the main enablers, it was also mentioned the need to evolve from the current ground communication because VDL-MO2 indeed is not fit for purpose. And we need an acceleration towards multi-link and ATS-B2. All in the room stressed that we need a common approach and that the global dimension is paramount. Also, the key role of ICAO was highlighted many times. I felt a general commitment to implementation, and indeed, we need to work all together, stakeholders, institutions, international organizations, and manufacturers, if we want, and we must, accelerate implementation. Today will be even more concrete, talking about the building blocks for TBO and how to move forward, considering that global interoperability is a paramount. We will hear also directly from the stakeholders that are already moving to implement and listen to their lessons learned. Well, I don't want to steal additional time from our welcome panelists as the schedule is very tight today. So I immediately give the floor to David to guide us through the next steps of the day. And indeed, enjoy the day.
Thank you very much, Maria Grazia. So as Maria Grazia said, we have a very full day and we're going to get very concrete. It's my great pleasure to introduce Mr. Paul Bosman, who is the head of the ATM Infrastructure Division at Eurocontrol, who will lead us through the next session on the TBO building blocks and enabling trajectory sharing.
Okay, thank you, David. Good morning, everybody. It's very good to see the room full again. Even the FAA came back. Yeah, as well. Hi, Steve. I couldn't resist. As we always say, the first day people come just out of curiosity, maybe the free lunch. Yeah, but if they come back the second day, there must be something in it. And it's very, very good to see so many of you here sitting in the room. As you might have guessed, I'm the entertainer for the next 2 hours in this big symposium. And after the what, after the benefits, the operational benefits, the R&D status, etc., today we'll start going a bit more real. Yeah, we need the technical enablers, we need technology, etc. And again, think about it. How many years was it that Steve Jobs stood up, showed the first iPhone, and we never knew we needed an iPhone until we saw it. Yeah, and that's going to be the session of this morning. You're going to get one technology after another. You go, oh, I want all of that. Yeah, and I want it now. Now, the good news is that many of these things are actually ready now. We're rolling them out. They're being deployed, etc. So I think it's going to be a very interesting session altogether. In terms of the speakers, we actually never marketed this session. They all bubbled up all on themselves. Yeah, and I'm very, very happy to see so many of you. I think this is by far the most popular session in terms of number of speakers, etc. And so I'm not going to steal too much of your time. The only thing I want to say, I don't think I have to say it, but it's going to be an open Q&A. So we really try to limit the number of slides, etc., and then we go open Q&A. Now, with technology, there's never shortage of questions, and perhaps agreements, disagreements, and all that, etc. We'll get through it. And again, with these 7 speakers, I'm very sure that we have really the best people around the globe here for you. The first speaker that I would like to introduce is from NM. So now, start of commercial break. I also am from NM, the network manager, and the network manager is very much known for its flow management, capacity balancing, etc. But we also play other roles. And one of the other roles, certainly on CNS, is the role of the CNS architect, the CNS program manager, etc. And we're trying with everybody all together, with the SDU, with the ASA, with Maria Grazia, and everybody, we really try to move things forward as fast as we can. And in terms of CNS, that means that we are running a number of common services. We're trying to debug data link. We're trying to move things forward with the best of our capabilities, etc. So that's what she will be talking about. End of commercial break. Veronique, the floor is yours.
What an introduction. Okay, so I hope you're enjoying TBO because I will again speak about TBO, but not directly about the concept, focusing on supporting technology. So first, I think we all agree that TBO is good for you. Triple purpose, as underlined yesterday, safety, capacity, environment for a single thing. Ah, it's me, sorry. So I will start with the left part of my slide. It's very dense, but I will be very quick. As I said, TBO is good for you, very simple things. You remove uncertainty, you share the trajectory, then you have ad hoc clearance, saving fuel, saving time, everything. I steal the slide from Peter yesterday. Thank you, Peter, for this slide. And then to underline this tremendous benefit, we have the multi-link business case and showing again the huge benefits we can expect from the technology. On the right side, maybe the pain point, or at least what we are focusing on today, the supporting infrastructure. So what we have today the current data link. What is behind VDL Mod 2? What is next? We have a lot on the file. We have the SATCOM, Iris one, the COTS technology, so known as hyperconnected ATM, and then LDACs as the terrestrial infrastructure. So all are either under study or near to being deployed. What is the roadmap? What are we talking about? We are talking today about B1. B1 is still being deployed, and we are transitioning slowly but surely into B2, or the first step of it being AF6. All of that's being ATC TBO operation. So here, figures are just obvious. Operational usage is raising up. The airspace coverage as well, the equipage as well. Why? It's thanks to our team, great dedication that allow this great progress on the technology. There's 2 maps, just one in the upper part underlying the service level of the login list, and the lower part, it's about the operational usage. So it's starting to work quite well, but it's not enough. We need, as underlined previously by Maria Grazia, this multi-link approach. What it is about. In fact, we need to supplement VDL Mod 2 with new links. First one on the list being the SATCOM Class B services, available services. So I guess Davide will come back on this, and some others that are today in the CESAR basket, I would say. So LDAX and the hyper-connected ATM. What is important to underline here is that IRIS implementation step has to be decided at the end of this year. So it's tomorrow's, but tomorrow very close to today. Then it comes with the initiative from the team as well, from our control. I was not there, but it was done, and it was a tremendous achievement to push forward this common data link procurement. What is it about? What is in this call? It's about the VDL Mod 2 as a baseline, supplemented, as we said before, by the SATCOM. So we will rely really strongly on the multi-link conclusion. Then DADC common server as an option. Why? Just to have service level agreement, to go for further monitoring of the infrastructure. And who is in there? 26 INSP. So you see the map. It's quite a huge success. At least I hope that we will have a very successful contract signature by September 2025. It's a future, but the future is really, really nearby. So what is the intent of this common procurement? It's to increase the performance. This is what is at stake for the data link. We need to improve the performance of the data link network, facilitating also implementation of new services and technology. We were discussing about the hyper-connected, that will come later, LDAX, that will come later. We need to be ready collectively. Then ensuring common prioritization on the solving of any issue, delivering certified pan-European services, and mutualizing the service delivery costs. And least but very important topic, enabling AF6. AF6, so you know it, initial intended projected profile, EPP, another nice name, just again, sharing of aircraft trajectory. Very simple use case, already operational in MUAC. You know it, you have seen it maybe before. Comparison of what the aircraft intend to do and what the ground is saying the aircraft wanted to do. And then you can optimize top of descent clearance. It's simple, but it saves a lot of fuel. So both coming back to the benefits of the technology, it's both about capacity, efficiency, and fuel effectiveness. To do that, Eurocontrol developed a lot of documentation. So we have the supporting standard for ADSC and EPP. Let's underline here again the tremendous work that has been done by the team to push forward all this, I would say, supporting deployment materials. So the CONOPS, the cover, the logon, the ADSC common services, everything is based on current and existing MUAC operation ongoing. So it's here to help. It's for you, ready for implementation. That's it for me.
Thank you, Veronique. And this is really how we like the technology enablers to be known, on time, even sometimes delivered ahead of time. Yeah, it will not get better than this. Now, for the non-Europeans, we don't ask you to understand us really in Europe. We're complex. Yeah, let's call it European problems, European solutions. So we have this big family of European institutions that together are moving European ATM forward. But how does this work in practice? Typically, Veronique mentioned the multi-link. Multi-link was started, initiated, worked out, validated by the CESAR joint undertaking. Yeah, and there are still bits and pieces of it are still in their scope. Yeah, then such things move to the CESAR deployment manager to further see, okay, what are really the benefits, what are really the costs, etc. How can we move it together? And then when it gets close to operations or into operations, that's when we in the network manager further pick things up, etc. So again, for the non-Europeans, don't try to fully understand it. Just know that we work really well together. Yeah, we got you covered. I think that's the most important message. Same goes, by the way, for the common procurement, which was an SDM initiative and then further worked out by us. So Veronique ended with AF6 and you go like, really? What's that? And for that, we got Heiko. Heiko will start where Veronique left it, and Heiko, the floor is yours.
Yes, thank you very much, Paul. Good morning, everybody. I think that was really a very good connection to the presentation of Veronique. It was mentioned several times, those two expressions, CP1 and AF6. What is really that? The CP1 is a regulation that we have in Europe called Common Project 1. It's a regulation number 116/2021. And certain ATM functionalities are defined in this regulation. And here we talk about the so-called ATM functionality 6, in short terms, AF6. And the first slide just depicts what's written in there. I think it's a bit of an eye test because it's very, very small, what you see here. But maybe I'll just talk about it and then you can read it on your screens. So this regulation is divided into several, let's say, parts. So the first part, I would say, is the airborne part, which mandates that all aircraft have to be equipped with the capability to downlink trajectory using ADAC EPP as part of the ADS-B2 services. Then there's a ground part, talking about all the, let's say, ATS units on the ground, where we have ATC systems, and those ATC systems have to be capable of receiving this trajectory and also processing it. And in case of there are any discrepancies between the downlink trajectory and the trajectory stored in the ATS systems, there needs to be a warning that has to be displayed to the controllers. Then we have the next block, the network manager, also a very important player. He should also use the downlinked trajectories to enhance his planning and predictability. And also the next block, also on the ground, we have to make sure that those trajectories being downlinked by the aircraft are distributed amongst the different ATS units and also between the ATS units and the network manager. And yeah, to end with this slide, the scope is this has to be implemented in all EU member states above flight level 285 until the 31st of December 27. So this is a very short recap and let's say summary of what's written in the regulation concerning the famous AF6. The next slide just gives a short state of play where we are. Also what has happened in the last months. In December 23, you could also see it in the slides of Veronique. Eurocontrol published the ADAC Common Service Technical Specification. This was elaborated in the so-called Operational Excellence Program and was also co-led by the SDM. In February 24, EASA delivered a report to the European Commission with an assessment about the outputs of the Industrialization Forum. And that report concluded that AF6 was ready for implementation. And on April 23rd, this year, 2024, the Single Sky Committee provided a positive opinion to the European Commission regarding the industrialization target date of AF6. And the EC has confirmed that AF6 remains in the regulation in the Common Project 1 with implementation date of 31st of December 27. And we as SDM, for the time being, are working on our CESAR deployment program. CESAR deployment program is the work plan to implement the CP1. And we expect that this SDP will be approved by the stakeholders through the Investors Buying Group end of June, the June 27th. And we also started to work now with with the stakeholders. We are pre-coordinating an implementation project. And there are two baskets. There's one basket where we will have the possibility to get some funding by European Union. So we will prepare a proposal. And there will be another basket where we can offer support to all implementing partners who will not go to the channel of the funding. So if you are interested in implementing the AF6, please get in contact with us. We are helping and willing to support you to really make it happen. That's our mission. The next slide is just a map which depicts the actual implementation status. You can see here on the green, in the green color, the airspace of the Maastricht UIC. Of course, that's a bit more. That's also the northwestern part of the upper airspace in Germany. But if you mix the two colors, yellow and green, that would be a very strange color being the result out of it. So that means Maastricht UIC is already operational using ADAC EPP trajectories since May 2022. And you can see in this light yellow color other ANSPs who are participating in the SESAR project validations, which concluded last year in June. And also we know that around 250 aircraft are already equipped, mainly Airbus aircraft with ADAC EPP capabilities. And resulting out of the EASA report in February 24, we as STM are in the process of preparing a questionnaire for the manufacturing industry, be it the airborne side or the ground side, to see what their plans are, if they've been contacted by their customers, what the roadmaps are, and we will use that as a baseline for further monitoring. And the last slide I would like to show you is an example of how this common implementation initiative could look like. That's the structure of a project that we would like to build with as many stakeholders as possible. And we would like to start with this work as soon as possible. Factory has already started. And so everybody who's interested to participate in this implementation initiative, give us a call. We are there to support and to help you. Here you can see the structure. We will have a project leader who is in charge of managing the project as such. We'll have the STM as a coordinator, providing support to the project leader and also taking care of the establishment of this ADAC service-based common definition. We have then the four blocks concerning the different families there in the project. On the left-hand side, you can see the airspace users. So this should refer to the aircraft capabilities to downlinking of the ADAC trajectories. We have the ANSP side of the house, the family 612, where the ATM systems have to be upgraded to be able to receive and process the trajectories and display the warning. We have the network manager, which also uses the trajectories to enhance their calculation and prediction of the trajectories. And we have the ANSP side, again, where we need to make sure that the ADAC trajectories are distributed amongst the ATS units and also with the network manager. So that's the, let's say, structure of the project. We are already in exchange. We started exchanges with all the stakeholders. So everybody who wants to participate is warmly invited to contact us. And we are here to help and support you, and we would like to make it happen. So that would finish the part concerning the building block in AF6, but we're also working on another building block where there will be another session that's also quite interesting. We as STM are also working on the flight planning, the pre-departure phase, where we are working together with a network manager on the FFI's topic. But there will be a following session that will also explain that in more detail. So that would be my part. Thank you very much.
Thank you, Heiko, and you guys, you're amazing. Yeah, one after the other, really on time, really fantastic to see. So what do we remember from Heiko's presentation? Christmas is coming early. Yeah, that's really the one. Heiko, you're going to be very popular during the coffee break, I'm sure. Heiko also very quickly passed over the fact that MUAC is operational with ATSB2 since 2 years. If ever any of you have an opportunity to visit the MUAC operational center, don't hesitate. I did it myself autumn last year. I sat down with a controller for 2 hours behind the screen, etc. My God, this is amazing. Yeah, the future is now. You see it happening in front of your eyes. Complex clearances around military zones with the mouse click, 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 uploaded, done, go. Yeah, difficult vertical profiles, top of descent, etc. Click, 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 boom, all done. Yeah, this in very, very difficult operational circumstances. One of their lead controllers, Victor, I'm sure that many of you have seen him in the different standardization activities, etc., very proudly announced to us the other day that he was, thanks to data link and ATSB2, etc., able to push, and now listen, more than 100 aircraft through the sector in 1 hour. Think about it, more than 100 aircraft. It's happening, guys. It's operational. It is there. So I can only say, run to HEICO, grab the money, and implement this stuff as quick as you can. Yeah. Now, HEICO. HEICO mentioned to us that there were 250 aircraft equipped by the end of last year. Hugues, I'm looking for better than that. Yeah.
Merci, Paul. I will be better. So you were in advance, Véronique and HEICO. I will try to be late. Let's start. So my name is Hugues Debecco. In Airbus, I am in charge of the air traffic management program. So we will start with building blocks. C'est moi qui ai la main. Paul gave you some appetite with technology with the iPhone. I will go through cooking. So here we see what we call the lasagna. So since we are good cooker, we want to master all the elements of the lasagna. So the foundations are the physical links between the aircraft and the ground. Before starting to jump into this description, here we focus on the aircraft to the ground connections. So it's only a part of the full TBO, quite important part, but it's only a part, and we will see at the end how does it fit in the more global picture. Second important statement is what said Paul about the environment. Here we are talking about continental dense airspace. 100 aircraft in a given sector for a controller is really huge. So here we are talking about things, back to my speech yesterday, where aircraft are going very, very fast. And again, the element of that is safety. So here we are talking about continental dense airspace to increase the efficiency in something which is already difficult. So foundations. The root of the foundation are the VHF Mode 2. You all know that, VDL Mode 2, plus the novelty, and it will be described this morning, which is the SATCOM L-band air-to-ground communication link with IRIS, thanks to ESA and Inmarsat. So this is real. It's in operation. There is a pre-commercial flight which are in operation, progressively entering into the real world. Technically, everything is done. It's a matter of having the last commercial connection, etc. So this is today. Going to the right of the foundation layer, we are talking about tomorrow. So Véronique mentioned that we need to continue to increase the throughput of the air-to-ground link. Yes, this is true. We have a problem to solve in some years, which will be, there will be missing bandwidth to communicate everything that we have to do. So 2 pillars, LDAX and hyper-connected ATM, and they are very looked at in detail thanks to CESAR FCDI project. They will use either a terrestrial network or another SATCOM link to make the communication. In the middle of the lasagna, the present is in the middle today, at the center of the slide. This is real. This is the famous air traffic network B1, which is in operation, data link, which has been mandated for many years now, and it is working every day, connecting the pilot and the controllers. Tomorrow, we are talking about the extended projected profile, the FMS downlink, the downlink of the FMS trajectory from the aircraft to the controller without any pilot actions, except the logon at the beginning of the flight. And tomorrow, there is a full ATSB2, which is complementing this link, which is from the aircraft to the ground by a totally closed loop between the aircraft and the ground and so forth, with a full CPDLC set of messages, which is allowing a total digital control of the aircraft or digital exchanges of the controller order to the aircraft. This is tomorrow. And 2 messages behind that is, first, this is totally standardized. We called about ICAO yesterday. What you see in the middle layer is the result of all the ICAO coordination, which led to the standardization of this layer. The second message is, this is real. This is flying in MUAC, and we will see later what does it mean. So when we say tomorrow, it's today. It's tomorrow in terms of implementation decision, but it is today in terms of reality. At the top of the slides, here is added value, here are the functions, and this is where it will be progressively increased for the first function, which is part of the famous CP1 mandate, which is the conformance monitoring. The way the controller is checking that the aircraft intended flight as defined in the flight management system is consistent with the ATC field flight plan. And things are already going further, in particular in WAC, because it's also used for conflict detection and resolution, because having a much more accurate and trust in the received trajectory allows the controller to improve his efficiency in controlling the airspace. Again, it will be presented today. To allow traffic synchronization, not only within the current ACC, but also to use for the AMAN at the destination airport to define with extended AMAN a better sequence of arrival, and even to make regulation in speed of an aircraft which is not yet in the area of controls. Complementing more complex environments, will be also the support, this famous EPP and B2, the support for dynamic capacity balancing. And last but not least, to manage very complex traffic sequence. So the lasagna, the conclusion on that is this is real, standards are existing, and it is just the beginning of the journey. Going from left to right at the upper layer will be the evolution of what it will provide to the entire system. What does it mean today in aircraft? So here we focus about Airbus aircraft. We started with oceanic data link, which is called the FANS A or the FANS 1, and it has been used for many years. The famous ATN-B1 is called, in terms of aircraft functions or options, FANS B, FANS B+. And now we have merged the full of FANS A, FANS B, and the totality of the ATN-B2 standardization is what we call the FANS C. So the FANS C is one step ahead in terms of content, because it is already dealing with tomorrow, and it's already ahead in terms of time, because it is available. What is the market penetration? On here, Paul, I am better than you figures. End of 2024, we plan to have around 420 aircraft equipped with the famous FANS C. End of 2027, around 1,100. This is before the famous AFC's mandate. Again, this is reality. And this is thanks to MUAC, to the energy that MUAC has deployed in showing that this is real, it works, and it provides value. And thanks to some early adopters who are in this room. Thank you. Voilà. What will be the next step? The next step is to put that functions in the other families, A350 and A220. So A350, the development is ongoing, and A220, the development is being planned. And I will finish with the big picture. So taking a step ahead at the upper layers than my lasagna, what do we mean? The lasagna is on the upper left, link, which is the safety critical link between the cockpit and the aircraft control, the ATC control center. Important, it is not only the one which is currently in command of the flight, but it is also a way to connect the cockpit for all the downstream ACCs up to destination airport. And here we call about the famous concept, which is the trajectory sharing. So this slide is focused on about this link, and we have to make the complexity to add all this in 3 dimensions to make airline flight ops control center is dealing with much more than one flight, and network manager is dealing with much more than one flight. So the complexity is around that. This is all here just a representation of different than what was presented yesterday. So still focusing on the role of the flight, critical communication will always go through what has been done for that and what has been standardized for that. Typically, this is a B1, EPP, B2. Here we are talking about safety critical links between a flight which is ongoing and the current ongoing ATC control center and all the ones which are down path. There will be, and there are, and this is on trial and this is existing, a link between the flight management system, the crew, and the flight ops control center. And this is opening a wide area of possible collaboration through the flight ops control center or directly with the aircraft control center, with the ATC control center, when we talk about non-critical collaborative decision-making. Again, remember speed of the essence. So speed and safety, we need safety critical links whenever it comes to control. But if time permits, CDM is being able to be made differently. These new links will offer more what if on real negotiations. But again, it will be possible only when time is there. What will be the future of these links? For sure, it will play a role, and it can be envisaged in non-dense area or before departure, etc. So all of that is a matter of deployment. Voilà. So the conclusion on that slide that it's not research, it's real. So there is still some research to be made. It was shown on the lasagna, but here what is linked at the upper part of this slide, this is a reality, and MAC is operating it daily. Merci.
Thank you very much, Hugues. You have no idea how precise he was on time. We have this counter here running, and at the moment that we saw 1 to 0 second, he said, and my conclusion is, so what do we remember from this presentation, apart from that he's a French cook? No, the most important is that it's happening. It's out there. It's in operations. And again, I need to stress, thanks to this really well-working single value chain between R&D, deployment, operations, etc., we're making things happen in Europe. And I think that's really, really important message. So for the next speaker, I'm extremely honored to have Sherry from Boeing. And just to say how honored I am, for those of you in Europe who know me a bit better, I never wear a tie. But for you, Sherry, I couldn't wear it.
Thank you very much for the symposium organization committee for this opportunity to connect, to share, and to learn. So Airbus Oak, my friends, did a great job on aircraft fence roadmap. And as you know, Boeing company, we have a similar roadmap for the fence. We are working with our airline customers. Try to find, and work, of course, work with CSR deployment manager, EASA, and other organizations to meet the mandates. With the limited time, I would like to focus on another computer on the flight deck, EFB. How EFB enhanced the flight deck to enable TBO operations. So from yesterday, there are many distinguished speakers and discuss about the shared vision for the future ATM, which is on TBO. And all those key building blocks like SWIN, FF5s, connected aircraft, and CPDOC, and so on. So I wanted to really start with, because the different regions, different stakeholders will have a different operational priorities. As we all know, given the modernization of the ATM, such as the next gen CSR program, CARET, and others, there are significant investments needed for the ground automation. In the meantime, as operators, airlines, and OEMs understood, fully know that there are significant requirements for the aircraft capabilities. So how we can find that sweet spot between these triangles? I didn't talk about this one, actually very important one about ATM procedures. regulations and play the whole systems acting together to make sure we can find that sweet spot. Traditionally, which is right, ATM modernization mainly focus on how we can enhance safety. Shout out to everyone in the room here. Thank you for all the great work, so that air travel is the safest transportation mode in the world. Now we are moving to how we can have secure, sustainable, affordable flight operations can enable millions to fly, to continue, enable our economy, continue the growth, right? So that's the fundamental question is what we can do. We need to focus on value-driving transition to TBO. Given that context, with the traditional way, anything we need, which is right, safety focused, we need to put everything from airplane side on the certified avionics components. With the increased information exchange and that kind of traditional way lead to somehow with an alternative solution. So I would like to get us introduced to the EFB. EFB is very, very popular right now in the airline flight deck operations. And when you look at my chart in the bottom of the timeline, when EFB initially introduced, how this EFB revolutionized on the airline's flight deck operations. Start with connect with our crew member, basically get rid of more than 35 pounds of flight navigation manual paperwork. Not just, not carrying that 35 pounds, huge environmental benefits, and the quick time for maintain, as we know, 28 days of cycle navigation updates. Then with the ARINC and the industry innovation, we get AOC data link. That's opened up, not just, get rid of paperwork and a lot of mission support capability to help pilot, such as the electronic flight folder briefing. You do the paper, before you do the paper briefing, print out, right now everything you can be done in this very small, tiny EFB. Then once you have that capability, you get it connected to the FOC to really enable not just voice by dispatch, continuous support and assistance to the pilot, and also and a lot of airline operation efficient and functions capabilities, such as real-time winds and updates, and the real-time, maybe the changes in need of a cost index due to the fleet management need, and so on. They will get a lot of capabilities and to enable FOC to support flight execution on the flight deck. As we all know, SWIN is the digital infrastructure for TBO. The connectivity enable flight deck to access SWIN information. So I was really triggered about 10 years ago. One of the ASP, which is FAA, approached Jepson and said, can we use your Flight Deck Pro to see how the SWIN information can enhance situation awareness? That's how we started with aircraft access to SWIN. And the pilot feedback was overwhelmingly like it. They feel it's got more information and more situation with awareness on the flight deck. In the meantime, with this FFI's definition, with FS construct, they are so much needed for flight deck involved in the collaboration decision-making. That's why we built some of the capabilities demonstrated in the 2020 4-dimension TBO flight, and also demonstrated that capability, which is so valuable. And last year's 2023 multi-regional TBO. In the meantime, we discussed this. This is important to get to the aircraft trajectory down to the ground to help improve the ground trajectory predictor. So we also downlink the aircraft through AID to EFB. When you look at the revolutionary of the EFB involvement from reduce, get rid of paper process, gradually move to up to negotiation and share the trajectory. This EFB with connected aircraft could make current existing airplane to be TBO capable. So one of the things key takeaways, I think they are common recognition and in US and in Europe for EFB applications. That EFB related applications, not safety critical handling, which is not qualified as an EFB anymore, which only need operational approval, doesn't need certification. So this is a huge benefit for how we can enhance EFB applications and so that can get quickly to the market. We know everyone in the room agree, B2 is the target, is a North Star. And in the long way to get the majority of the airplane equipped with EFB, and here in Europe, equipped with EPP, sorry, the EFB solution might be complementary to address existing fleet issue. And the EFB solution for other regions might be a good way instead of depends on, as noted, very expensive, time-consuming time and execution implementation of a ground automation system to enable this B2 CPDOC or B2 message construct. EFB might provide a flexible way to do that. So in the meantime, when we studied that, we know EPP is very, very accurate for short-term prediction. With our flight text and the simulation, we do know there were conditions, and we must have very accurate forecast of temperature, winds in the FMS, and when the aircraft need to be fly by autopilot, we did a couple of use cases actually in the night flight demonstration when the aircraft was deviated and manually controlled by the pilot because deviated by controller, and the EPP downlink is not accurate. So there's a mechanism needed to in place. So in the words, I think we need to think how we can get to the market quicker, use this EFB. Traditionally, we were doing that absolutely right. any safety related the information right now, we need to stay with a certified component. But with ATM, TBO required more information exchange, how we can use EFB. Actually, we demonstrated that in our TBO live flight demonstration last year. So we have, actually, I welcome you to visit our booth. We recorded some of our use cases demonstration on the flight deck side, and very important, I have not say, very important piece is on the ground side, optimizer. Why this small EFB is powerful? It's not itself, it's the connectivity, it's the able the connectivity to the ground optimizer to get all the real-time information. So that's why can make this flight more business, more close to the business profile, the trajectory. That's all I have. Thank you very much.
Thank you, Sherry. And I think it was very good to see the complementarity between the Airbus, Boeing approaches, etc. I mean, I was trying to think in my head, do I continue with the metaphor of the iPhone and say, well, it doesn't matter we use an iPhone or a Samsung with Android, etc. I mean, yeah, but then if you really think it through, I'm not sure that is perfect metaphor, so to say. But I think what is important that also as your research is indicating is that the benefits are uncontested. Yeah, I know, very similar to the benefits that we saw from other presentations. Also for you to know, in Europe, we're looking, of course, into this as well through the CSRGU. There are activities ongoing to look at the FMS EFB connection, looking at downlinking information, uplinking it in different ways, etc. It is not as mature yet as what you saw from the Airbus presentation. What is important for us, also from a network manager perspective, is come on, guys, get it going, test it out, validate it, implement it, because the operational benefits are really clearly there. Yeah. So again, Sherry, thank you very much for this one. So it's time to get our feet on the ground again. You know what I'm going to say, Jason. Yeah. Yeah. Jason has a job title called Director TBO. I mean, thank you very much. We're honored to have you here. Jason, the floor is yours.
Thank you, Paul. I knew you couldn't resist. So my name is Jason Roster, NAV Canada. So this presentation that I'm going to give here today is towards the building blocks that NAV Canada is implementing to support the concept of trajectory-based operations in our environment. I'm not focusing on the detailed, excuse me, technical changes, but rather the high-level elements that we see as being required and what that deployment consists of. My colleague Blake Cushney will be expanding on these elements from an operational perspective later on in the symposium today. So just to set the context and why TBO is important to our operation, you can see that the airspace that NAV Canada manages is very large, over 18 million square kilometers, including some of the busiest oceanic traffic in the world. It's comprised of 7 flight information regions, which really behave almost like independent countries in themselves because of the way that we've implemented procedures across the country and because of the diverse nature of the country as far as airspace is concerned. And we also have 4 major airport hubs within our airspace, that being Toronto, Montreal, Calgary, and Vancouver. Those, what we call the 4 majors, account for almost 30% of our overall traffic in our airspace. So as you can see from this density view, there's really 3 major flows of traffic that we predominantly deal with, and that's really the east-west flow, our oceanic traffic, and to a large extent, all of the traffic that is going into and out of the US airspace. So why is this important? With such a large airspace, we have an ideal environment for developing and deploying the tools to support TBO and providing benefit to our customers. Whether it be the pre-flight stage, the en route stage, the arrival stage, or the interaction with neighboring ANSPs, all phases can be considered as part of our TBO deployment. So we are all sitting here today, participating to look at how do we deliver benefit and predictability to the users of the airspace. But essentially from an ANSP point of view, the goals are to provide a structure that, number one, provide the necessary constraint information back to users so they can conduct the most optimum flight for their operation. And number two, for us as an ANSP to provide the necessary management tools to manage that flight operation from departure to landing. Sorry. So when you look at our current state, we're kind of limited from an optimization perspective for a number of reasons. Number one, there's no single instance of the entire trajectory of a flight. Although flights are filed with the intent of operation, that flight data may not be propagated across all of our systems until a certain point prior to boundary crossing. Flow management is airport and FIR centric. We do operate a national traffic management unit. However, the tools are configured more as FIR based or one of the major airports based. There's no single NAV Canada system that is used to monitor that national, domestic, or oceanic for that matter, a view of the airspace. No single high quality data record. So as an example, as users file their flight plans today with intent of speed and altitude changes, that information is stripped from the original flight plan into our system. So we're not even modeling a trajectory that takes that into account today. Airspace modernization, another key element that we need to progress upon. So concepts like flexible use of airspace. And in this context, I'm not referring to the flexible use of airspace between civil and military airspace. I'm more referring to the ability to move airspace around either within a particular area of responsibility or between adjacent centers. So as an example, you can consider our oceanic flow where, depending upon the time of day or the flow of traffic, it may make more sense for one center to be managing that traffic versus another. So limited data exchange here, another one that, so each center today has a very good view of what is important to them. However, there is no real easy way to see what is going to be the effect downstream of any changes that are occurring locally. So as an example, consider the knock-on effect of being in one center doing speed reduction or speed increases in that center, but in fact, in the next center, you have to vector or hold that aircraft. So that information is not necessarily propagated. So what does our future state look like? So we see three major components here. One is the centralized flight data trajectory management. So this will support the filing and management of user preferred trajectories, including any constraint feedback to the users. So this is essentially our FFICE implementation. Whether this will be legacy flight plan 2012 filers or FFICE capable users, during the initial phase, it doesn't really matter. We'll be managing that one central trajectory and publish to all interested clients and systems within our environment. Distribution between systems will be a standards-based FIXM format to increase the automation, reduce the likelihood of rejections, and also the localized updates to the local clearance will be passed back to that central trajectory manager for synchronization purposes. Network management. The introduction of a national flow management system will be responsible for that overarching view of the entire system from a capacity and demand perspective. That one system be responsible for, we'll have one view of the data, however, multiple roles within that system. So we may want to have it at the national level looking at the data for strategic view, more of an FIR-based role view of the data, or even from a specialty base to where I'm interested in demand into my particular sector. Another key element of this system is the ability to support strategic clearance coordination with any tactical position if necessary. So prior to FFICE R2, and even during R2 phase, there will be a need to perform strategic changes to airborne flights. And as you've seen, we have a large airspace, so we can do that. The capability allows the network manager positions to inform any tactical jurisdictional position or controller of the ATFM measure for that flight and monitor the implementation of that clearance to the aircraft. ITEC. So I'm sure many of you have seen the recent announcement that NAVCAN has joined the ITEC consortium to deploy within the Canadian domestic airspace. From a TBO building block perspective, we see this as a very large part of our strategic vision as it provides for the collaboration and common implementation of functionality between like-minded ANSPs as well. R&D support. In our environment today, we have very extensive testbed environment. We do develop and integrate a number of systems. However, we do see the benefit in expanding that to include more of industry partners as well as our airspace users to develop the processes and flows that are going to be necessary in the future in a TBO environment. So what is required here? So really three major items. The number one is data exchange. To support the exchange of data between diverse systems of users, SWIM is a mechanism for this. In addition to SWIM, the applications need to be built based on standardized exchange models. Equipage. To reduce the variability in trajectories, we also require fleet equipage to ensure those trajectories are being adhered to, as well as providing reassurance that the planned trajectory will be met. An example of this is equipage to support PBM procedures within the airspace structure. Another would be the ability to exchange complex clearances via CPDLC and the exchange of or reception of EPP data to support trajectory synchronization and conformance monitoring, as has been mentioned previously. And time-based management. So increased predictability through time-based management is really how we manage the trajectory once we agree upon it. And so those are the tools that we introduce for the ATCO positions. So from again, back to a building block perspective, how are we approaching this? So we see this as really three major phases. As far as the first phase, localized capabilities. So these are occurring now. So we're introducing our centralized trajectory manager that is in development. We're introducing our network manager capability. This initial phase will include preliminary FFISR1 components. In addition, when I talk about time-based management, it's all these predictability tools that we'll be implementing as well, and actually have implemented things like time-based service at our four majors, the arrival manager, extended metering, departure management, as well as sophisticated weather tools, which will provide that capability to provide feedback to our users when we see interruptions occurring because of weather influencers. The next phase would be our initial TBO, where we start looking at enhancements to our flight data processor, as well as looking at, well, what does FFISR2 look like and how we will start to deploy that. And then finally, from an optimized TBO, that is when we really get into that stage where we have the EPP downlink, whether it's the connected aircraft, how we're synchronizing that into our trajectory at the local FDP. So that's when we get to the full optimized TBO environment. So in conclusion, from a key building block takeaway, I believe there's really the thing to remember is that this is an iterative process. TBO is not a switch that just gets turned on. It's not a system. It needs to be planned for, it needs to be in multiple phases. It needs to have multiple areas of implementation. The other key takeaway is that the collaboration needs to be there, whether it's with the customer or with adjacent ANSPs. Sharing that overall ANSP roadmap with key stakeholders is imperative. So currently we're working on a data link roadmap, which we're really kicking off as to where we see that evolving for our environment. And then what benefits would be realized for early adopters of say FFICE and what information is important to them. So we can't do this in isolation to provide constraints if that constraint information is not important to the users. So all of these things need to be done in collaboration. So that is it, Paul. Thank you very much.
Thank you, Jason. Actually, very impressive to see this roadmap. I mean, in our European way, we're struggling, and sometimes it's only till recently that we started to create a European TBO roadmap, yeah. And then to see your roadmap so clearly articulated with these timescales for a lot of things to happen in this decade, I think is really very encouraging to see. And we will be very happy to continue the close cooperation to really make sure that we learn from each other, etc. So no, really impressive. You mentioned the FFIs. You said initially we go with maybe the standard flight plan and then we start looking to fix them, etc. We in the network manager, we went operational with the extended flight plan for FFIs 2 years ago. And we all know the flight plan. We love it, we hate it, whatever type of relationship you have with it. But when you go to a FIXM extended flight plan, I mean, think different. Yeah, it's not human readable and it is big. Yeah. And we keep on adding bandwidth, we keep on adding servers to our systems, etc., as more and more airlines are starting to switch on their filing of extended flight plans, etc. So again, this is still, although we give you here a picture of everything being really great and fantastic and going smooth, it's also hard work. And you continuously need to monitor a lot of things, etc. And that's also the bridge that I wanted to build with the next presentation. In that sense, TBO is very much like artificial intelligence. It needs CPU, GPU, energy. We need all that. And we need for TBO as well, we need bandwidth as much as we can get. There is no limit to the amount of bandwidth we need between the air and the ground to exchange all this information. And it is with great pleasure, Davide, that I give the floor to you for this one.
Thank you very much, Paul. And thank you very much for having me in this distinguished panel. So I think that the title of this presentation is very clear. What is IRIS SATCOM doing to support TBO today, tomorrow, and not only in Europe, but worldwide? But before getting into that, I need to set up a little bit the scene. Just a couple of slides. This is intentionally oversimplified, so I apologize for that, but it's good enough for me to set the scene. So I see 4 main enablers for TBO: ATS-B2 avionics, air-ground data link, then of course with the NSPs, the ATS-B2 services, and FFIs, and whatever is needed for a collaborative environment. It was said yesterday many times, so I don't need to convince anybody about that. Also, the title of this symposium is Global TBO Symposium. So it's a global opportunity, it's a global domain, and it's also a global challenge. But if we look at the global situation today, at least to me, it looks like this. In Europe, we have ATN-B1, of course, and some limited ATS-B2, thanks to MUAC Eurocontrol, which is an icebreaker pioneering in that sector. Of course, we have also some limited FANS 1A, we must have it. But we have that the ATN data link services are not yet widely used, at least I would say, not yet as much as we would like them to be used. And the VDL Mod 2 technology was said many times is approaching saturation. When this is, I think it's very controversial, but I think it's fair enough to say that it's approaching saturation. In USA, we have FANS 1A, which is another kind of data link, ACARS based. Then, of course, it was mentioned also today, we have FANS 1A in oceanic and remote. There is something going on in South America, very recent. And in the rest of the world, I would say that it's fair to say that we don't have a real data link. Now, having said that, I think that one can say that today data link services are not interoperable and are not globally deployed. And we have also IPS in the pipeline. So this is a challenge. What is IRIS SATCOM doing to contribute solving this challenge? And now I get really into the content of the presentation. The first point is that SATCOM, IRIS SATCOM, is a data link and is fully compliant with ATS-B2 performance standards. So one of the elements of the first picture is addressed. Of course, it's not only B2, it's also B1, but here we are talking about TBO, so let me put in the slides only ATS-B2. Coverage, we know that TBO is a global domain. We have immediate coverage in Europe, which is already operational, as it was already said. before. But IRIS has already an intrinsic global coverage because thanks to the satellites of Inmarsat, now Viasat, there is already a global coverage. I said it before, VDLMO 2 is approaching capacity limits. IRIS is complementing VDLMO 2. IRIS Satcom is joining forces with VDLMO 2 in a dual link fashion, which means that when IRIS Satcom is not available, it switches to VDLMO 2 and vice versa in a completely transparent way for the users. Avionics, I mentioned before, we need ATS-B2 avionics. In IRIS, we have contributed to support the enhancements of the Cobham Aviator Satcom terminal in order to be able to handle ATN OSI and dual link. And this is fully certified, it's flying, and it's part of what is today used operationally. We have another parallel line with Honeywell, which is the Aspire 400, which is 1 inch from becoming a product. And here, of course, very much depends on the view of Honeywell, how to handle that. But this is also a Satcom terminal, which is capable of ATS-B2, in particular EPP. It was already said, EPP is mandated in Europe as from 2028, actually 31st of December 2027. So this could be a possible way how to address this also with the Honeywell equipment for the, I would say, for the Boeing business. Now, I mentioned it before, IPS is coming. So what we are doing is currently we have the standardization, the SARPs of IPS, which are on track at ICAO. Next week, there will be an important, very important meeting, DCIWG, that they will have the pleasure to participate in person at ICAO in Montreal. And the IT and IPS SARPs will be on the table for approval. But we have also developed already a system. Of course, it's not a final system certified because the standardization is not yet finalized for IT and IPS, but it's a system which is as close as possible to a product. And with this system, we will run, which is already committed, is already in the schedule plan. We will have IPS flight trials by the end of 2024. And we are in discussion with Boeing to have an extension of that also in USA, still to be confirmed, by the end of 2025. But what is very important is that all these IPS test flights, they will use the ITN OSI IPS interoperability gateway. So they will be interoperable. So this is the way how we on IRIS Satcom, we are trying to address this interoperability issue that I was also mentioning before. And now beyond Europe, we have contacts with several civil aviation organizations in several places in Europe. I cannot go too much into details because of some commercial sensitivity, but we are already trying to expand IRIS beyond Europe. And what we get from the stakeholders outside from Europe is that they are very much interested in using Europe. And when we ask why, they say because of TBO. And when we ask what kind of TBO, and that's maybe a little bit, just not too much surprising, the full TBO, not just EPP. They want to go to the full TBO. Now, last 2 slides, very, very quickly. A few of the main achievements that we managed to have in the last couple of years. In July 2023, the ESSP, European Satellite Service Provider, has been certified by EASA as IRIS service provider. Since January of this year, we have commercial aircraft from EasyJet on Airbus 320 aircrafts that are flying in Europe. We have most of the European NSP who have signed a legal agreement to join these pre-commercial flights, which are using these IRIS flights and the IRIS Satcom in an fully operational way. And we have other airlines in the pipeline, like ITA Airways, which are expected to join very soon. And this is my last slide, and maybe the most important one, at least from my point of view. So I don't know if all of you know it, but the current performances of these flights, so far we had more than 1,000 flights since January of this year. They are public available to everybody. The ESSP is publishing these performances in near real time. That's the URL link if you are interested. And from this website, I've extracted a couple of pictures The first one is the one that I see on the right, which gives you a little bit a visual overview about where these flights are flying today. These are not really the actual routes, but this is where the CPDLC messages have been exchanged. So it's good enough to get an idea. And I have also another picture very similar to this, in which instead of the CPDLC, we have the ADSC, which have been exchanged with MUAC in an operational way. And quite a lot of messages have been exchanged with MUAC for ADSC. On the left, there is two things. There are some graphs with some colors. This is just the different type of data, ATN-B1, ATS-B2, and so on. Not so much important. What is important is what is on the left. The color code of what is on the left is important. Everything is green, at least so far. This means that the performances that we are measuring so far, it's only 3 aircrafts. Of course, we will see in the future when we will have hundreds, thousands. This is just the start. I'm fully aware of that. But the current performance are going well beyond what is demanded by the ATN-B1 and ATS-B2 standards. So the performances are met with quite a large, I would say, buffer to accommodate for further, I would say, further data and so on. So I think that's it on my side. Thank you very much.
Thank you, Davide. Davide was a bit hesitant because he still had 20 seconds left on the counter. So no, I think this was yet again a very good presentation. We from our end are quite excited by these commercial trials that are going on at the moment. It is true, as you said, David, there's only 3 aircraft at the moment, but many more are in the pipe. And we are excited. We're following this up very closely. We're working with the different ANSPs that are using this as well, etc. And it's looking good. And it's looking good to relieve the pretty busy video mode 2 bandwidth, etc. It can be used for the AOC traffic, etc. I mean, this has really a couple of benefits, etc. But it comes with a cost. And so the big debate that we have in Europe at this moment, are we ready to pay for it? And that is the discussion that Veronique also referred to, that we're trying to channel through what we call the NDTech, the NMB, etc., putting everybody around the table, discuss this through. But again, if I see the operational benefits of TBO, I don't fully understand where the hesitation is. We should be doing this, rolling it out, etc. But again, that's a debate that we're going to have later in the year in Europe. So with that, we have one more presentation left. And what we realized in the last couple of years, as we're starting to deploy and roll out TBO, etc., is that we really cannot leave any stone unturned. And we always talk to the usual suspects, and you see them sitting here as well. But we also need to really loop in and work very closely together with, I call them the enabler of the enablers, the ones that we don't talk about that much, the ones that live more in the background with their systems, the infrastructure, servers, etc. So we started to think differently about it. I think we have a very good working relationship. We're also going through initiatives like this common procurement, replacing all the national contracts with CETA, ARINC, etc., for a common procurement in Europe, etc. We'll do anything to move this thing forward. And in that sense, I'm really happy for you, Philippe, to be here. Please entertain us for the last bit.
Yeah, good morning, everybody. So yesterday, looks like we set up a sort of tradition where every speaker made a definition of what is TBO. Okay, so let's play the game. But I'm providing the network layer. I'm providing the ATM automation system. I'm providing avionics, data services. So from my viewpoint, what is TBO? I won't enter into the details, just share more information to more stakeholders. That's all. Nothing fancy. And then I'm trying to find a consensus to give the airline, as much as I can, the best business trajectory or fairy tale business trajectory to give to the ground stakeholders maximization of their capacity. It's a common problem. It's called optimization problem. I found it in multiple industries before I was working for other industries. But aviation is a very specific ecosystem. And when I sum up the keyword and the technology that were listed yesterday. Basically, on the application layer, everybody is talking, okay, I'm launching, sending an ADS contract, and I will retrieve the EPP data. Oh, and Peter was mentioning, okay, I create complex clearance. I use CPDLC service, another ATS application. Okay. And yesterday, and even today from Hugues and Steve and Olivia yesterday, there is even new interface, EFB. EFB is a complex system. I mean, AIDs, aircraft interface device, connect to the avionics buses, is able to interface cabin SATCOM, Wi-Fi in the cockpit, cellular. It's complex. So we have a diversity of networks, diversity of technologies we need to cope with. Okay, it's complex. So Maria Grazia yesterday was mentioning, I need building blocks, something basic with well-identified function I can update according to the needs of the community developing TBO services. Okay, so trying to structure a little bit, what does it mean, building blocks? I realize it covers multiple layers, multiple domains. The first one is the network services. Paul and Veronique are here, so it's critical. I mean, it's critical and complex and diverse. Coming from legacy telco, I mean, it's very basic. Telco is MPLS line, IP, dual stack IPv4, IPv6, border gateway protocol, VPN, and that's all. In aviation, it's really more complex. We have this VDN mode to network. We try to encapsulate traffic in other traffic with ACARS over IP. We are also working next-gen data links, so multi-link, IPS, and we see coming new data links. We were discussing IRIS, LDAX is coming. People are mentioning also cellular. So it's becoming a complex ecosystem to manage. And we are only on the network layer. Interconnect, wow, okay. We are interconnecting together data consumer, data producers, and we see new data producer or consumers, EFBs. Discussing with Thomas NSP, we have also the need to interface or to access other data. It's becoming really complex. Not talking about distribution. We were talking FFI, SWIM. What is exactly the scope of SWIM? Is it on the ground only? I heard multiple discussion about extending SWIM even in the airborne domain. What does it mean for the communication pipe? What does it mean for the cybersecurity service? And not even talking about the application layer. I mean, CPDLC, ADSC are ATS application. What does it mean on the EFB? It's diverse. And as an avionics supplier, but also as a network supplier, every time there is a new standard or a new technology, I need to update both sides. Avionics, ground systems, and automation system too. Okay, so one warning or one notice, I know there are network engineers here. What I did is not to try to stick to the OSI layer, 7 layers, or the TCP layer. It's just a way for me to articulate the discussion. So don't try to map this layer with something technical. It's not a technical brief today. So starting with the network layer. Okay, what do we need? Paul every day is in my bag and say, I want a robust data link network able to cope with the future needs, EPP, TBO operation. Yeah, it makes sense. Okay, so we have short-term initiative, we have long-term initiative. Short-term initiative is, I'm not Google, I'm not Apple. I cannot tell my NSP, I cannot tell my airlines, hey, you know, next year, January 1st, your stations are obsolete. No, I need to keep backward compatibility, even if new technologies are coming. So I need to optimize existing systems. So we have initiative that we work with the Eurocontrol, Airbus, the OEM. We can optimize the protocol. People familiar with data link know the non-use of IDRP, to give an example. We have also what we call the offload the network. So, okay, today we have VDL mode 2. So let's analyze the traffic. And for non-safety critical traffic, let's move this traffic to something else. IRIS is a very good example. Basically, we just created a very customized specific load balancer. And capacity increase. Yeah, we are already working on the next gen, moving from OSI to IPS, looking for the integration of Iris on your network. And we are also monitoring the LDAX, multi-link, hyper-connected ATM. We are on those projects. Okay, but they are legacy interface, VDL Mode 2, ATSU or CMU in the airborne. Okay, but we see that new needs are popping up. 4 or 5 presentations yesterday and today were mentioning EFB as a potential data link involved in the TBO operation, either to interface the FMS, or there are nice ideas around managing the unconstrained trajectory using EFB. Okay, I don't know what will be the final implementation, but I need to be flexible to cope with this type of request. So yeah, what we do is we discuss, we monitor, we are part of the working group to identify what are the trends. And if we see something new pop up, I mean, we integrate this new need into a roadmap. Or if it's a product co-developed with a partner, let's say AIDs with Airbus, for example, FOMAX, it's something that we will discuss together to agree and to include this new technology or this new interface into a roadmap. Then I need to share data. It's the basic principle of TBO. So, okay, we were mentioning FFIs, release 1, release 2. We were mentioning SWIM, okay? When I'm discussing with ANSPs, major ANSPs, I see a new need coming. They say, yeah, TBO, we may need to access data from the airline. I put on the side any discussion around data sharing agreement, okay? Here I have ANSP, they say, oh, if we know this parameter from the aircraft coming to this airport, I believe I can give a better service to the airlines. Okay, what does it mean? Is it something we will distribute through SWIM, or is it something that will be more specific because it's something more open? I don't know yet, but I need to anticipate. So we are involved in another CESAR project called CNS Data Service, where we try to define this concept of ADSP service, ATM Data Service Provider. So maybe it won't be used, but maybe yes. So it's a way for us to anticipate and be ready if there is a new need popping up. New application, of course, by application, I cover both the ground side and the airborne side. So yeah, Hugues was mentioning, and a lot of presenters were mentioning ATSB2. Of course, the avionics, we are ready and we have started to develop those avionics. Same for the ground. When Iris is coming, we are working to interface Iris as another communication pipe. But beyond that, we are also participating in CESAR. We have, for example, an application that does flight profile optimization, single aircraft. I mean, our goal was not to be global, but we provide this application to the community in the CESAR project to assess and have a starting point to be able to contribute to the FPO and TBO operation. That being said, it was only the technical aspect of TBO. Of course, it won't be a single delivery. So we won't say, okay, at this date, we will deliver TBO global deployment and it's done, voila. No, it will be an incremental approach. So with incremental roadmap. So we need to be agile. I hate this keyword because it's used everywhere, but it's a good summary. It means that we need to be flexible because multiple iteration will be required. That being said, what I would like is to get the support of the regulators. For example, we welcome any initiative from the regulators able to support us. For example, data link with the ACDLS initiative. I hate to manage 26 contracts and I hate to have the same feedback from multiple channels. And we really welcome ACDLS as a way to federate and unify feedback and working together. He has a conformity assessment framework. It's really an example. I'm not exhaustive here, but we welcome a single stamp, of course. And we really appreciate more that when we see in other regions, when ANSPs are releasing RFP more and more frequently, they are referring to European regulation. So yes, we work on it and we welcome it. Standardization, of course, as an implementer, we don't want to implement a solution in Asia and a different solution in America and another one in Europe. So we really welcome any initiative to standardize. So thanks to EuroCAE, RTCA, ICAO, to give a global framework that we can comply with. And again, somebody yesterday during a presentation mentioned and said, nothing is free. Yeah, nothing is free. So we welcome any funding to incentivize early movers and to create a very positive momentum in our industry around TBO. That's all for me.
Thank you, Philippe. I am deeply impressed by the speakers. This event, as you can imagine, has been well prepared by all the different parties, etc. We have a 14-page document that describes minute by minute what is going to happen, etc. And we're sticking to it. Yeah. So I'm really like to thank you for that discipline, etc. So now they've done their job, they've done their part of the deal. Now it's yours. Yeah. Until 11 o'clock, we have an open Q&A session. So the floor is yours. We ask you to ask your questions. When we give you the floor, please, yeah, we're coming there. Yeah, please state your name and state your organization, because that helps the whole audience and also the person who's going to enter to understand from which perspective exactly you're coming from. With that said, you're the first one.
Thank you, Chairman. Robert Winker from DFS. I've got a comment to Heiko's presentation. I really appreciate what you presented, especially in regard to MUAC. But we would appreciate if the MUAC part of Hanover UIR would be presented in your map as well.
Heiko?
Yes, thank you for the comment. I think we will take that on board.
At that speed, we're going to have time for a lot of questions. Eh? Yes, please.
Pascal Colès, Air France. I would want to react to the Boeing presentation about EFB. Just to say that I fully agree with what Boeing presented about the EFB and the role of EFB today as a tool for the pilots. It is true that today the briefing package, weather data, updated weather data going to EFB to the cockpit and used. So it is clear that EFB is an alternative, probably an alternative means of compliance for CP1, but it is not the case today. So my question is to Brian to say, Brian, are you considering the EFB tools as an alternative means of compliance for CP1? Because, of course, for us, it is an affordable mean to increase the critical mass of aircraft and users and to react to what Philippe said, to share data with the ground, because it is already ready today. So, Brian, are you considering the EFB as an alternative means of compliance for CP1?
So I like how the dynamic is developing here. I see Boeing already nodding, and I see Brian trying to hide below the desk. Brian.
Oh dear, I should have been later than I planned. The traffic jam this morning cleared too quickly. Sorry for that. I must admit, I've heard before this event, I've heard mention of EFBs and how EFBs could support TBO. I was not fully aware until today how sort of advanced that thinking had been. So the use of TOBs from our EFBs from our perspective probably needs a little bit more thought process, and we probably need to discuss a little bit more with the researchers and people who are developing it, what they intend to do, how they intend to link it with the whole system, especially the avionics, and how they want to do that, and how they can ensure all the security around it. So we need a little bit more thought. It's the first sort of time it's really come up in discussions I've had. Maybe some of mine more seats hasn't come to me in any other format. How to answer your question, Pascal, directly? It's very difficult. to answer. Could it be an MS, an additional? It probably could be. But again, I'm not quite sure how. You will use the EFB at this moment in time to downlink the EPP data, which is generated by the FMS. What is the linkage you're going to put in there? How are you going to ensure it's the security? How are you going to ensure that? So there are lots of questions that need answering, but if you can answer all the questions, maybe yes, but I'm not committed to it today.
Okay, respect, Brian, to pick it up there. So Brian, by the way, Brian Jolly, he's from EASA, for just for you to understand the whole context, etc. Sherry, please.
Thank you, Ryan. Thank you for the question. I would propose during the coffee break, stop by our booth. We can have a little bit deep dive. Thank you.
Yeah, I think just to give you a bit further perspective, I think Brian was very right when he said the EFB solution is very much still in the R&D phase. I think it is too early to, at this moment in time, say this is a full-blown, mature, validated replacement or complementary for what we're trying to do with the ATSB2, etc. And let's also not forget, why was this put in the regulation in the first place? Is because we desperately need the operational benefits. Yeah, Europe can't wait for these things to have another 5 or 10 years before this is fully mature, etc. I gave you the example of MUAC. Yeah, other ANSPs are very actively working on rolling it out as well. We need this, guys. Yeah, and again, refer back to Razvan's presentation yesterday. Traffic is back, or to what Jacopo said yesterday. Traffic is back. People want to fly. Yeah, we're back to pre-COVID traffic levels, and we're going beyond it in several places in Europe already now. So we need these technical enablers to be rolled out. Okay, any other questions? Anyone? Yes, behind you, please.
Yeah, it's Michael Nachtigal, Lufthansa. So it's like always that Pascal and myself, we're having the same questions in mind. My point, because I would like to add on that as well, is because you always mention one EFB, there is not one EFB. So that's something which is important to know, that the EFB are platforms which go far beyond the scope of ATM. So it's a platform for business continuity. No flight will take off today or tomorrow if there would not be an EFB. So that's something to take in mind. And my question in this regard is, how do you ensure that the commercial choice and the, let's say, the selection process and the control of the EFB platform still stays with the airlines? Because that's our essential production tool, what we have in place and what we use in the future as well. And it's totally contradictory, for example, to the typical avionics setups where you have a standardized set of technology and a small set of providers who are actually producing this kind of stuff. So what's your strategy, especially in this, to add on Pascal question, the question to Hugues and to Sherry from Boeing. So what is your OEM strategy, how to bring together this kind of commercial individual decision-making of the operators with the highest reliability and standardization requirements we actually need for this kind of solution? Thank you.
I don't know if anyone wants to answer that. I just see the nodding happening. Sherry?
That's very good question. Actually, as you all heard about it from yesterday's presentation, Armon's description on the multi-regional TBO and my speak on the EFB. I think the fundamentally is we look at what actually required from the ground automation perspective. And this is an easy way in our perspective from the R&D, right? It's a gateway. Then we can measure if the EFB pass, basically it's FMS information. It's just use a different path to get to the ground automation for operation improvement. So I would challenge if we could set up something like test bed to validate it, test it, and then could get widely, implemented quickly, because as we all know, it's the time to the operation is critical for whole system enhancement.
a tricky question. So starting by referring to the presentation I made, here we are talking about safety critical link between the crew and the control. And the first safety function is the conformance monitoring. So for that reason, I would say there is no escape. The standardization is there. This is called the B1, B2, and EPP, and we will rely on that. So the Airbus overall roadmap is very simple. We have already 2 aircraft which are equipped and flying, and they are still flying, already flying A320, A330. So they are in advance in time and in content because as I explained, they are implementing the full B2, which is far more than the mandate. What about the others? A350, they will implement the mandate for the date and the development is ongoing, and we still have some difficulties to plan the A220. This is not a novelty. I've been saying and explaining that for 4 years now. Anyway, again, we are talking about the safety link between a crew and the ATC. And the reason of that is here we are talking about TBO in one of the most dense and complex areas in the world, which is Muac, Karlsruhe, Reims, and now it's moving to some other places because it's dynamic. So the density of the traffic is moving in Europe, and we can see it. It was presented yesterday by Jacopo. So here, EFB is not the solution, not at all. What about the other areas, and what about the other use case? Obviously, there are many other areas, and it was also said that TBO, there is not one solution, one size fits all. So EFB could be a real complement in some other areas, having the advantage to be retrofitable, which is, I admit, and the question of Pascal behind the question is a retrofit, and making the retrofit of the full B1 of the AF6 or B2 is not in the plan today. So regulation is only for forward fit, because we have to remain humbled, economically speaking, and also because we consider that it does not need to grab some benefits to have all the fleet equipped. And this is very important. So EFB is a very good means to make something better than today and to have a retrofitable solution. And as far as we talk about the mandate, here we are talking about safety critical link. Voilà. So this is where we lie in Airbus. And last but not least, I think that Paul, you insisted a lot. This is not research. The standard is there for the EPP and the B2. It's just a matter of implementing now. The concept is there, is that it has been matured thanks to ICAO for many, many years, having all pilots, controllers, ANSPs, regulators, etc., defining the standard. So this is important now that we just implement what we have been developing and imagining so far for many years now. Voilà.
Okay, I think I would like try to close a little bit this topic. I think there's many other technology aspects that we would like to discuss, but again, I think Hugues, you summarized it well. This is all validated, this is standardized, etc. It's a matter of rolling it out. It doesn't mean we should close our eyes. Yeah, more R&D is required in the CSRU. Andreas is nodding. Yeah, we are picking it up. So Europe is engaging or is engaged on this topic as well. But let this not be an excuse not to move now. Yeah, we need these operational benefits as quick as possible. Any other questions? Yes, please.
My name is Regula Dettlingot. I'm an aviation lawyer. So among all these technicians, I have maybe a little bit a different perspective. As mentioned yesterday, I was the chair of the performance review body of the Single European Sky. And this gives the buzzword, Single European Sky. If I listen to all these technical developments, I'm really struck that this could be a game changer in the sense of overcoming fragmentation. Because the European Court of Justice in 2017 published a report saying that all the technical investments that had been done had not enabled to overcome the fragmentation of the European airspace. And I'm listening to a colleague from Canada. Even there, the ACCs have challenges in the same airspace to overcome their own plans. So is this a realistic expectation now that this TBO approach is helping to overcome fragmentation And we have heard it is needing regulation, but what would be the regulation needed? Is it affecting the sovereignty, which is always the elephant in the room if we talk about standardization, because each country says, no, this is my airspace, and invokes the Chicago Convention. So I would be interested to hear from the technicians, is this now going to be a game changer? Thank you.
And this is where the volunteers are all stepping. Heiko, is this something that you would like to put your teeth in?
Yeah, okay, maybe I can start. I think that's really a very complex question that maybe not can be answered so easily. But I think the first step, and this is also one of the prerequisites that we will talk about later, also when we get in this topic of FFIs, that one of the prerequisites could be that the more data we share, the more common awareness is there about the different phases of the flight, and the better also decision can be taken. Also taken into account, I think it was also mentioned by Jason, one of the presenters, that we have to be more aware what's happening also, let's say, on the downstream side. So if I fly from, let's say, Stockholm to Zurich, that I don't, let's say, ignore everything which is, let's say, beyond my airspace boundary. And I think this could be even, let's say, a big first step. Because now, if you come from current operations, you know that a lot of people are more or less just focused on their own airspace, their own sector, and say, oh, I don't care what's happening, let's say, beyond this airspace. And I think this kind of possibility now to share common data, to create this common awareness, and also to say, okay, I also have to care about what's happening at the, let's say, next downstream air traffic control center, or even the airport, I think is very important. And I think that's the first step in the right direction.
Thank you very much. Hugues.
Thank you for your question. And by the way, I will ask you to help us in solving it. I explain. Sovereignty and fragmentation are really the key words, in particular in Europe, but not only. Here we are talking about technology, and we know that fragmentation of the airspace is an institutional difficulty to improve the air traffic management worldwide. So here we are talking about a new technology which is changing the game, which is true. I would say for the sake of the efficiency, and in particular to the third duty we have, which is behind safety, punctuality, which is to improve the CO2 impact of ATM, we need absolutely to solve everything. So if sovereignty and fragmentation is a possible showstopper, we need to work on it now. My perception on that is it will not. What we are describing in technology is just additional sharing of information which are already shared. So we are just making it better, more fluent, but it should not really totally shake the entire system. The one who still will be in control of a given flight will be the controller. And this is not changed by this current status. And with respect to sovereignty, I think here relies really the technical aspect of it. So this being said, we need to work on that. We cannot wait the end of the story to be stopped by legal or sovereignty consideration. So it's a very good question that we need to put on the to-do list. And I am absolutely confident.
Okay, thank you, Hugues. Davide, you were next.
Thank you. I mean, I have a very simple and very short answer to that question. I think that technology now is ready to provide the required performances to enable TBO. And then since TBO requires the collaboration of everybody, I think that this will help reducing fragmentation in a way or in another. For instance, NSPs will have to collaborate even more than what they are doing today. So otherwise there is no TBO. So I think that this will reduce fragmentation in the future.
Okay, Sherry, and then after that, I think we're going to move on to the next question.
Yeah, this is an excellent question. And that's actually we did the flight demonstration last year for Flynet 2 from Tokyo to Singapore, overflying Thailand, and many ASPs without participating in this TBO demonstration. And the critical part, that's why this framework or provision defined by ICAO FFIs, which provide the common struct to exchange information. And in the end, the operators actually has this magic wand, the optimizer, be able to stitch all the constraints along the flight path together. That's really could help on the harmonization interoperability issue. But in the meantime, as we noted, there are not of great technology standards be mature, like B2. We know we all wanted to go to B2. And but in the meantime, why we have all this fragmentation? Because the investment, significantly investment needed on the infrastructure. So how we can find that is sweet spot, and that's the key for the more harmonized interoperable TBO in the future, very near future we want to do.
So, Regula, you see it, yeah? The house here is full of engineers, and engineers, they have solutions for problems you didn't even know you had. Yeah? So count on us. Yes, I think I saw a hand already first here, then I come to you. Yeah, please.
Good morning, Omar from the Sultanate of Oman. As a NSP, I heard Philippe mention the word cybersecurity. What is the European experience implementing with all this data link and data being shared in all this project?
It's not a green picture. Yeah, we are suffering it also as a network manager from it increasingly. It has impacts in lots of places, etc. Maybe Veronique, you can start with it on the data link impact.
On the GNSS RFI, you mean? Yeah, so we are monitoring it weekly. We see the impact for sure because we are relying on GNSS all over CNS for surveillance, for communication, because all the CPDLC messages are timestamped. So in case you have a GNSS outage, then you can lose the data link. So we are working on it very closely. We are monitoring the situation, but as of today, we have no real solution.
It's a bit of a hard reality on it, and again, we're working on it.
Sorry, but the cost is shared between the ANSP, the IRIS, for example, or who deals with the cost of protecting the data?
David?
Yeah, maybe I just, of course, I can speak only about IRIS. I mean, IRIS is a data link which is secure. Now there is security embedded in IRIS, and I mean, also Airbus has played I would say a strong role in defining the type and the level of security that was required. So it started from I would say from the avionics. The concept started from the avionics, and then it was flowed down to the ground segment, so that there was a peer-to-peer, I would say, equivalent also on the ground segment.
Yeah. So what Veronique was also referring to, and what I was referring to, is that what we see at the moment through to GNSS interference, the clocks in the cockpits get affected. Yeah, maybe we can fix that through an operational procedure. Maybe you need to do a bit of rewiring in your cockpits, etc. But it is something that needs attention. Yeah, Heiko, before we then move on.
Yeah, maybe just to complement what was already, let's say, said. We have this CNS program management and the network manager, let's say, part ongoing. And also I think there the CNS program manager is thinking about CNS minimum operational network, which also tries to find ideas and ways how to overcome these challenges and define a minimum operational network that we are at least able to protect some of the, let's say, ATM operations that we are conducting in Europe.
Thank you for that one, Heiko. Okay, please.
Good morning, everyone. Ulrich Kage from Frequentis. I'm coming from data management, more or less, and we hear a lot about data links, and it's really a lot of information. So I'm seeking a little bit for clarification. Yesterday, I think we heard from Boeing that they have a data link between aircrafts and AOC, where they can exchange data, and also, I would assume, also a trajectory. On the other hand, we talk about data links very much towards ACCs, through ADSC and then uplink to CPDLC. And why I understand that the second one is still in the works and will require to retrofit aircrafts. It sounded yesterday like the data links between aircraft and AOC, they are already there. And my question is now, is this how is this in the whole data link context? Couldn't we just submit the trajectories to the AOCs and just do it through ground distribution? So it's really, maybe it's a stupid question and uneducated, so I'm seeking for some education. Is there competition between the AOC aircraft data link and the aircraft ACC data links, or how is it handled?
I
And
think
how
from
will the
a-
system look
yeah,
like?
we would never think you are stupid, Ulrich. No, really about that. No, I think you need to see it in the, where are you in the phase of flight? Yeah, if you're still pre-departure, then of course the AOC has the best possible information, and that's why we want to go for the extended flight plan filing. At the moment that you're in flight, then it is the FMS that has the best possible information of what the intention of the aircraft is. I think that's the very simple answer. And we need for TBO, at any moment in time, we need to have the best possible information that is available. Yeah, but I'm sure my distinguished speakers can explain this in further detail.
In a sense, it was the purpose of the very simple representation that I provided with the magic square. This is where, so I call it. This is the focus about the link in the overall picture of TBO, focusing on the link between the flight in execution and the overall system. And whenever it comes to having a link between someone outside of the cockpit and the cockpit, we need to make the distinction about whether what is the nature of the link. And if we are talking about controlling the aircraft, or providing information which is allowing the controllers to have a more accurate view about what the aircraft will view, then we are talking about safety link. And for that, we are relying on the existing standardization. And it's not research, it's just a matter of doing it. There are aircraft which are ready. Now the question is to develop it in the ground. So this is the famous B1, B1 CPP, and tomorrow, which is already today in some Airbus, B2. And then the ESB is complementing that. But it was never the intent of the FMS to ESB to AOC on the ground link to overpass this link. It's something which has been existing, by the way, much before. It is already in flight in most of the airliners with the ACARS link, AOC of the FMS, but it was never thought for that purpose. So now the question is to say, can we reuse something which has been existing from the past for another purpose? And this is what Thierry has presented, what I have presented on my Magic Square representation, but it will require further R&D to define how to make it good use.
Question. I think, Christos, you were just before Torsten. So, Christos.
Thank you, Paul. My name is Kostas Christoforou. I'm from IFACEA. I have a twofold question. As I realize, we are going for a gradual implementation of this concept. So my first question goes, are the stakeholders willing to go for a harmonized transition plan on this concept? And the second part is, as we foresee some operational and technical changes from this implementation on the regulatory domain, all these are going to be covered by the European EU 373 regulation, or do we need to search for a new regulation? Thank you.
1 minute we have to answer that one. I'm looking at Heiko again. Yes.
Okay, I think also they are a very good question. And the first part is if the stakeholders are really going in the direction and really working together to make it happen. I think also one of the first major prerequisites to this is also this kind of common awareness and the common understanding of what we are wanting to achieve. And I think this 3-day workshop is one of the best prerequisites to achieve that. And I guess you can also feel the spirit. So now the next step will be, of course, to build a kind of implementation roadmap based on the declaration of the stakeholders, that would be the next step, something that we are working on. And concerning the second part, the regulatory topics, I think for the time being, everything is covered, what we have in the existing regulations. That means the Common Project 1 and also the 373/2017 that you were mentioning.
Yeah, but that said as well, is that some bits, as we just heard as well today, are still in the R&D phase. We need to see how that comes out, and then we need to see the operational harmonization needs, etc. And then we need to see if standardization is enough or whether we need more to really make sure that we get the orchestrated, timely implementation, etc. Okay, I think we're gonna put this to an end. Very sorry, Torsten, but we're available to you during the break. I would like to thank again the speakers for all their good contributions. I think what we've seen very clearly is that despite the fact that there's still a couple of things out there for R&D, I think there's really big chunks now that are deployable, deployed, operations, etc. And I haven't heard anything that stops us from implementing that further. We need these operational benefits that we saw yesterday, and everybody was rolling over each other about, I have another one, etc. So the technology is there. So that's not the issue. There's also a lot of passion. You saw it in our speakers. And again, I thank you very much for that. And best of all, Heiko has the money. Thank you all again for your time. I've been honored to be your moderator and entertainer. I hand the floor back to David.
Thank you very much, Paul. When we organized this symposium, we knew we were taking, or we thought we were taking quite a risk in setting up an almost 2-hour session with 7 presentations. I have to say, Paul, you did a fantastic job in keeping that going. The panelists also in making that a very engaging discussion. I think the time flew by. That said, you've definitely earned yourself a coffee break. So we will break now for coffee. I want to tell you that all of the presentations that you've seen are being made available online on the Eurocontrol website. Please go and visit the exhibition outside in the lobby if you haven't had time, and we will start again at 11:30 sharp. I would like to ask the panelists and presenters who just presented to stay in the room for a photograph, and then you can go and have your coffee. Thank you.
Check test 1, 2.
We are about to resume, so please take your seats. So welcome back after the coffee break and welcome back to the online participants as well. So now we will move on to talk about really the global dimension. We have a session on taking TBO global. And for that, I'm very pleased to introduce again Crystal Kim, Technical Officer for Airspace Management and Optimization at ICAO, who will lead us through the next panel session. Crystal, the floor is yours.
So, good morning. Good to be here. And again, it's a great pleasure to moderate this very interesting session, and could be a little bit difficult session after we listen to this wonderful, great technical developments that are already out there, that are implementable. And our speakers in this session is going to share with you what are the challenges and opportunities and how we could overcome those challenges together. Before we go into the presentations from our speakers, I don't think I can be as entertaining as Paul, but I'll do my best to keep you engaged and address all your questions and concerns during the given time. I still have a few minutes to go. So before we actually get into each presentation, I'd like to share a little bit about what ICAO has been doing to ensure this global interoperability to support the TBO implementation. We all heard that the way that TBO moves in each state in the region could look different. However, all stakeholders on the global level should have a common understanding on what TBO is, what is the scope of the TBO, and what are the key enablers that will bring us to realize the TBO, so which we all heard yesterday. So the ICAO has developed the global concept, which describes the definition of TBO and what are the enabling capabilities and what are the set of technical enablers that will make those capabilities possible. And what we also have done is what are the timelines for ICAO together with the industry stakeholders to make all those enablers in place, which have been laid out in the Global Air Navigation Plan. Subsequently, ICAO has also been working with all of you, regulators and industry stakeholders, and also the research and development organizations. We've developed a set of global standards to support those key enablers, namely FFIs, SWIM. Both standards are going to be applicable November 2024 this year. For data link, we already have quite a robust set of provisions that supports the interoperable use of the data link system that have been deployed in the last 20 years. You've heard about the book called GOLD, Global Operational Data Link Document, which is one of my babies that I've worked in the last 10 years. That document clearly describes all these advanced capabilities that ATS Data Link will, no, not anymore, it has already been deployed in some parts of the world. It's just a matter of the implementation decisions. So, and all these ICAO documents cannot really stand alone, need to be at times complemented by more detailed technical specifications by other standard making organizations like RTCA and EUROCAE. So in this session, do we have enough to ensure global interoperable TBO implementation? I don't think so. That's why we have this session, right? So today we will hear about what are some lessons learned to prepare the implementation of the key enabling capabilities from Mr. Magnus Malbeck from Cesar Deployment Manager, and also Mr. Lucas Kearns from FAA, who's been working on FFIs and SWIM implementation in the US, and Mr. Brian Jolie, Senior ATM ANS expert from EASA, who's been working on regulations to allow you or to enable you the implementation of these enablers. Last but not least, Mr. Michael Bryan, who is the CEO of the Closed Loop Aviation Consulting company, and previously Qantas pilot, who have witnessed a lot of initiatives in the aviation industry in the last 30 years. So without further ado, I would like to invite our first presenter. It will be actually a joint presentation. Mr. Magnus Malbeck and Mr. Lucas Kearns. Floor is yours.
So good morning, soon lunchtime, and we get to entertain you a little bit about everything the next 15 minutes time, and we hope we can keep you awake. My name is Magnus, and this is Luke from FAA. So let's go into the details, and Luke will start.
Yep, and just up front, you saw an acronym there beside my name, CSSFD. So that is going to be the FAA's implementation of FFIS R1, and that stands for Common Support Services Flight Data. And a little about why we're here today together. So the US and the EU have a memorandum of cooperation on air traffic management modernization, civil aviation research and development, and global interoperability. It involves coordinating next-gen and CESAR projects in an effort to support global harmonization between our implementation of ICAO concepts and technologies. The Deployment Coordination Committee, or DCOM, is within the MOC and was formed to assist with the coordination of deploying and planning of the implementation activities. The DCOM group consists of FAA and EU specific subject matter experts that would really focus on system-wide information management, flight and flow for an information for a collaborative environment, and data link. And within the DCOM, Magnus and I are focused on SWIM and FFIS. And today we're going to share a bit about what we're doing there, the importance of this work, and how it's going to support the global harmonization of these important ICAO concepts.
Great. So we are not only working together because of the MOC, just let's make that straight. We are here together to try to discuss the interoperability. We see the need, and there's a need for global coordination on it. So what is FFIs? We've heard talk about it now a few times today. It's probably, we hear often in Europe, since we have a mandate, we hear people say it's pure cost, no benefit. You're just having us implement things. But that is the thing about enablers. They are necessary to move towards trajectory-based operations. So FFIs is about where we are moving towards a new format to try to deal with the limitation we have today. So today already airspace users file a desired trajectory or the wish for where they want to fly. And this is also what we're moving towards, that they can really get to fly the trajectory that they desired. So they file that to the EASP, the Enable ANS provider, and then they agree on a trajectory that is then distributed to ATC. So initially, what is happening now is the release 1 of FFIs, the pre-departure phase. But what is important is that it feeds execution. It feeds FFIs release 2. It's not different from today, where flight plan feeds our execution, our mechanism. It actually is the core of all ground system. It's the flight plan. It feeds into everywhere. And last but not least, I think we always forget the SWIM. So we are changing the mechanism. We will no longer use AFTN, AMHS, etc. as we know it. We're moving towards a new mechanism of exchanging flight plans here, but in general. Still me, mandate. I don't think Luke wants to start with that. In Europe, Heiko mentioned it already earlier, we have a CP1 regulation, common project, and associated CSR deployment program. FFIs is mandated in Europe, and that means it's a European mandate with a global impact because it's an airspace mandate. So all airspace users operating within the European airspace, that is the 27 EU states plus Switzerland and Norway, of course, including Murg also, are mandated to file an EFPL as of 31st of December 2025 when flying here. And on ground, the ANSPs will have to update their ground system, both to receive it via SWIM, but also to use it in operation. So European mandate with global impact.
I think it's an important part there with the global impact because it will have an impact on our US airspace users that they fly to Europe or through Europe. And it has been a positive experience for us having the mandate be implemented here in Europe. It's really helped facilitate additional conversations in the US with our airspace users, and it's pushing to have those conversations more frequently than we might have already on our own timeline. So really have gotten a lot of good feedback and helping to understand all the concerns from airspace users that we're getting through this collaboration with CESAR in Europe. Now on to benefits. So I'm going to focus on the airspace user side. And when we look at the airspace users, I want to focus on really two main points here. With the collaborative approach in the flight plan filing side and the trial and preliminary services within FFICE will provide advanced knowledge of constraints and provide insight into current issues that could cause airspace users to change their original flight plan. So with those constraints, driving the need for a different and more efficient flight plan based on what might be an issue out there in the airspace. And having fewer changes to flight plans ultimately getting filed will be a big benefit there. And then the 4D trajectory is a main piece as well, with having that specific performance data added into the EFPL now within the new format and having the enhancements for trajectory predictions by air traffic managers, allowing the airspace users to file closer to their optimal desired path.
So we heard already that FFICE is operational in Europe. So both the network manager have implemented. You'll hear more from Augustine in the later presentation after lunch on that. However, we also have airspace users. Lufthansa is already filing EFPL, so FFICE flight plans in operations. And therefore, it becomes very important to think of benefits for airspace users also in the ground system. So how will ANSPs actually take usage of this information is the big question that we are talking about in Europe here, because we want to do a lot. We've heard that the last 2 days. Trajectory-based operation is the word that we hear everywhere, but how will we do it? And initially, the initial benefit that has been identified is, in the end, it's all about increased data accuracy, which can be used for multiple purposes in the ground system. And that is what we are looking towards. For example, an earlier and more efficient conflict detection, less false alarms, etc. These are some potential benefits that we are looking towards on the ground.
And now looking at some of the differences between Flight Plan 2012 and the new EFPL. So the Flight Plan 2012 was really based on teletypes in the 1970s. So it's got limited information. It's a manual process. And compared to the newer EFPL that's going to be rolled out with FFICE, having that richer and more digital information and 30 new EFPL information elements, along with that 4DT that we already mentioned. And with the Flight Plan 2012, we're looking at that anticipated sunset date of 2034, I believe, is what the dates that we're actually pushing to there.
So we're talking now about, first, there's a mandate in Europe for IFR traffic, but we're talking about a sunset for Flight Plan 2012 overall, meaning that means all flights. VFR, IFR, everything is said to be sunset in 2034 now initially. I think it will still be subject to probably some discussions. However, what will change? What is the change? So Luke talked about the different fields we have in the flight plan, and there will be a new element. There will be plenty of new information that we could potentially benefit from. Because today, in the end, ATC, we're limited to this ATC flight plan that is filed with us. That is not the information that the airspace users sit on. They sit on more information. So often there is an operational flight plan that the pilot is using for the operation, but that information is not often the same that we have on ground. So the ATC flight plan is used by ATC and the operational flight plan by the pilot. That is what we are trying to put together here. With EFPL, it will be one. So we will actually enable the possibility of sharing all the information that the pilot has today with ATC for the benefit of the ground computation, trajectory, etc.
Yeah, and one of the key aspects of the DCOM group that we work on is focused on collaboration and stakeholder engagement. And to accomplish this successfully, we're first working to understand the differences between our implementations. Looking at the current EFPL business rules that's done in Europe and understanding what we can look to harmonize with in the United States as we're looking to do the implementation of EFPLs as well. Looking to see what might have to be changed, what would be the same, if there's any differences that could cause issues for airspace users. Last fall, we submitted an information paper to ATMRPP to review a lot of these findings that we did. And one of the important outcomes of this, and a point that I wanted to note, is that the presence of regional extensions within an EFPL should not cause an FFICE flight plan to be rejected. But we should implement a filtering mechanism to put that in place to be able to strip out or ignore those regional extensions, with the end goal to minimize any impacts on airspace users when you're filing to different regions.
And with this collaboration, it's very interesting to see that by talking about a new flight plan format, by talking about the changes, we also start looking at the current problems that already exist with flight plan filing today, because it's not either simple today. I think airspace users, CFSPs around in the room probably know all about this, and this is something that we need to ensure will not become more difficult in the future. So, because looking at Europe isolated, we receive flight plan from more than 50 different countries globally. We have more than 900 operationally active airspace users, so not all of them are commercial, but that brings a lot of complexity. Likewise, in the US, you see the traffic flows. We to the US and from US and Europe, and to Europe, we have from everywhere basically coming. So in the US, you have around 190 commercial carriers, and I think we have commercial more than 385 in Europe, if we look at the lists now, all of which probably have different systems. If we look globally, then there are local laws globally that imposes specific rules for flight plan filing in countries. There are countries where we still have manual processes, et cetera, et cetera. So we're looking at a very complex global picture, and that's why the collaboration is crucial between actors in Europe for the benefit of airspace users.
And to really focus more on that global harmonization and need for it, as Meg spoke about, the different airspace users, the amount of traffic that's out there, and with the EFPL and FFICE, it's not only a format change to the flight plan. It's going to be the additional information that we mentioned. It's going to be a change from the current infrastructure where flight plans are submitted from AFTN, AMHS to the new SWIM information networking services. FFICE would introduce that additional information for the 4DT. And really what we're trying to show here with the map is that the work that we're doing has been great through the DCOM and with that coordination, but the alignment between the US and Europe won't be enough. We're still going to need to coordinate with other regions, understand implementations around the world to ensure that it's interoperable and filing the flight plans can be consistently done no matter where an airspace user is filing. And with the color schemes of the map here just shows the coordination between Europe and the US, and then the coordination that's started between the US and NAV Canada. And with the APAC region, there's lots of forums there that we've started coordination and collaboration, with more to come there in the near future.
The joint timeline and common approach. So this is what we are trying to achieve, a common approach to FFIs. bearing in mind that we're not aiming for one global approach, but to minimize the impact of interoperability, because we know that we live different globally. We have different countries, processes, airspaces, etc. Taking the Europe timeline for it, so we have mandated a subset, the majority of the services, the filing, trial, flight data request, notification service has been is mandated, and the publication service also. It's not shown here, but it is mandated in Europe. So this is mandated to be implemented by law 2025. However, looking at it, you can see that we have actually started an initiative in Europe, and we don't expect everybody to be fully transitioned on the ground until 32-ish timeframe.
And for the US timeline up top there, you'll see a couple different lines, and this all reflects back to the implementation of FFICE, which is the CSSFD program. We did a risk reduction activity that ended in January 23, and that was really focused on trial plans and flight plan filing to understand concerns and get feedback from participants that we had in that risk reduction. We had 9 participants that helped out with that to provide that information and feedback on what we deployed. And then we're looking to deploy FFICE R1 into 2 different phases. So there'll be the first phase, we're looking to deploy in the 28-29 timeframe that'll focus on flight data sharing, flight plan filing, the trial service, and then phase 2 will come in later to finish out the R1 capabilities.
And the seconds are ticking here. It stresses us out, I think. However, the summary, we are moving towards trajectory exchanges. Richer flight information, improved planning possibility, improved decision making, and improved flow management initially. But potentially, as we heard from NAV Canada, part of ITEC now, we're looking at global cooperation on ground systems. We can not only look at the filing of information and the receive, we need to look at also the distribution, because the system need to have similar capabilities on the ground globally all of a sudden now, which is also a little towards the question earlier about that. How do we overcome fragmentation where we start implementing similar system globally?
And we're out of time.
We're out of time.
Thank you.
Thank you, Magnus and Lucas. The presentation clearly reiterated the expected and potential benefits that we heard yesterday through this tangible implementation plans, through a collaboration between 2 major organizations that covers big part of the global airspace. They also talked about the way they approached the deployment. One was the mandate, and the other one was more of an voluntary choice of an implementation. And they also touched based on the global sunsetting. Again, yes, there is a target date set for 2034, waiting for the responses from the global community in the upcoming ICAO 14th Air Navigation Conference over the summer. And the presentation also covered about how do we bring the rest of the world together with this more aligned approach. Again, one of the strategy that ICAO is pushing is regional approach. Once this target date is agreed upon, the next layer of the task will be given to each region to come up with their realistic aligned plan for implementation of FFICE. With that, I would like to invite our next speaker, who will talk about how the regulatory activities has been going in support of TBO.
Thank you, Crystal. Good morning to everyone. I hope everybody's enjoying everything so far. I'm here to maybe, shall we say, you've heard a lot today and yesterday about the research, the benefits, and everything that's going to be brought by TBO. Maybe as a regulator, I need to bring you back down to earth slightly. Okay? But I'll try not to bring you back down too big a bump, so we can actually keep going forward with this. I think everybody's recognized that it is a good system. It will move forward. It will bring benefits. But from a regulatory perspective, let's see how we can enable this here in Europe and here and globally to move forward in a great manner. So I have a very short presentation. What is TBO? Well, tell you what, I will miss this slide. Okay, because of time, you've all had lots of presentations over the last couple of day and a half to define what this. Let me not define what that is. Okay, I think we can all agree what that definition is. But in that definition and that way of working, we have talked about TBO. We have talked about who it affects, how it works. These are all, and I highlighted here some of the affected parties that that's been defined to affect TBO. TBO must be implemented by these parties to make it work. But these parties, of course, in Europe particularly, I'm sure it's in more member states, are subject to regulatory framework. This is a sample. It's not all the regulatory framework we have in Europe. So don't pick me up if I missed one. It's just sort of a sample. So how, it's a question, what do we need to adapt that regulatory framework to support TBO? The research is defining the concept, or has defined the concept. Let's ask that question. Well, we'll come to that at the end, okay? It's defined what the operations are going to look like. But again, that has got to be reflected in this framework. So what are the roles? What are roles, responsibilities? What are the certification requirements? What are the oversight requirements, et cetera, that have to be put in place to enable this to work? Without that, I'm afraid I will say that TBO will not happen in a harmonized and conventional manner. It'll be Wild West. I think the term Wild West was used yesterday, yeah? It'll be used again. It'll be Wild West. We've got to have this in the system. Furthermore, as a regulator and as a safety agency, we have to assess this, what this impact is. As we put TBO in, what is the impact on safety? How do we make it interoperable? If it's not interoperable, how does it affect safety? There was a comment earlier, I think, about security. How do we make it secure? What are the requirements for security as well? Does it need to be secure? That's another question. Does it need to be secure? I think the answer to that is yes, but okay, but it's a question we need to answer. Yeah. So it's there. These questions need to be answered. I'm not going to focus here on anything particular as it's to do with a particular system. I'll talk a bit more generally about how to implement it globally. So what do we need to deploy? We are already deploying some of it here in Europe, the basics here in Europe. So let's not talk about that per se and focus on a particular subject. You've heard a lot about FFIs and today, this other presentation, you've heard about other things going on. But we need to know what the benefits are, what the positive benefits are, what the negative benefits are, what the costs are, yeah? Let's assume this is an example, yeah? And I think everybody around here can probably agree it gives us more efficient airspace operations, more predictability in that way of working. However, to get that, what do we need? What is our target implementation objectives? We need, yeah? Who are we going to target to implement first? I heard, I think it was yesterday, I think it was the SDM, forgive me if I got it wrong, said to get the benefits, we need 70% equipage to get the benefits they're predicting, yeah? Okay. And I will go to fact, 70% of what? Okay. What is the framework we're looking at? What is the air-ground combination we're looking at to get that 70%? If I use, we talk about IFR traffic, yeah? If I use European terminology, so forgive me, are we only talking about CAT operations? Are we talking about NCC? Are we talking about NCO? Are we talking about SPO? Which is our target operations? Because every time we talk about a different operational class, we bring different problems in. I heard a lot about EFBs. Let's not go into the discussion about EFBs again, really. But EFBs are used differently in all the different operational people, yeah? So if it's an EFB-based operation where the EFB has to talk to the FCO, this changes the operational concept for all those other operators other than CAP. But is this what we want? These questions have got to be asked, okay? And have got to be firmed out. So we know who our operational implementation and operational objectives are to get the benefit that we want. Okay. So it's good to talk about these. These questions, to my mind, have not yet been answered. Okay, they still got to be answered if we want to move forward. And also, I come back and we've spoken about it more already and other things. We need known requirements, yeah? An apple has got to be an apple all over the world. It can't be an apple here and an orange in America and the US. Okay, it must be the same. We must have harmonized requirements, harmonized standards. We must be talking the same languages. The data transfer protocols must be the same globally. If we don't do that, it's not going to work. These have to be integrated into the regulatory frameworks to make sure things are correct and can be overseen and implemented correctly. So what is the key to success? Well, quickly, it's always a jigsaw to make it work. We have the concept. I would think maybe we can say, can we put a tick in the box? The concept is agreed. I think we can say that, or is it? Maybe a slight tweak here and there, and we can agree the concept. But then we have to define the compatible solutions. These are in work, okay? But they need to be defined, finished. Research has to finish. But also research mustn't become the evil to good intentions. I'll use that terminology. We can always improve. Sooner or later, we have to say, we've reached enough, we've got enough, let's move on and implement. We have to have agreed plans. We've got an ATM master plan here. We have the ATM, we have the GAMP, we've got other regional plans. It's nice to have those aligned, but there's a line. But we need more, probably, I hate the word, we had the discussion yesterday, roadmaps. Maybe we need a little bit more level roadmaps, implementation roadmaps, when things must be ready to actually make sure we can get implementation. So there's a question about regulation. Do we need regulations? What type of hard regulations do we need to move forward? Standardization and regulations. Of course, these are a must. We need to take the ICAO SARPs, ICAO GAMPs, not GAMPs, sorry, DOTs and PANs, and make sure they're fit for purpose. Maybe transfer those into the work of the EUROCAE and RTC and other standardization bodies. Also, we are talking, another question, do I also want to use specific ATM standards and AVM standards? A lot of this is data transfer, IP protocols. There are a lot of standards out there, ready commercial standards. Will they be fit for purpose? We need to answer those questions so we can actually implement properly and know what we want to implement. Let's not reinvent the wheels. Let's move forward correctly. I want harmonized requirements. I've already said that. That is a must. I will leave you with those thoughts. Of course, no hard questions, Pascal. Okay. So thank you very much for that, and I give it back to Crystal. Thank you.
Thank you. Thank you, Brian. I think he actually gave us a great checklist when you actually sit down and think about what to implement among a suite of solutions or the capabilities for the TBO. And as you mentioned, please keep all your questions just for one more presenters, then we will open the floor for addressing all your questions. Just to keep a short summary of what Brian mentioned was, when you look at the your implementation plans, look for the benefits based on the problems that are urgently need to be solved, which could bring the actual value after your investment. And also all these checklists that we're going to revisit during the our panel discussion. With that, I'd like to invite our last speaker to the floor, please.
Oh, I gotta move my thing. After what we've seen and heard, you've been forgiven for wondering why everyone isn't lined up around the block hollering for TBO. The subtitle here for this part of the symposium provides a clue. Let me come back to that. To begin with, let's go back a few years. Mostly the backs of heads, but some well-known industry luminaries are in this room. ICAO introduced this group to TBO and SWIM in their presentation as hosts of the EFB Users Forum in Montreal in 2011. The point is that this group, mainly airline flight technical pilots, was blindsided by the pronouncements. Most had been working on developing EFB programs for over a decade and trying to shoehorn the EFB into the status quo of airline operational concepts. Then they promptly forgot about it. This was the year of the iPad, and getting that device into flight decks was sucking oxygen out of industry strategy everywhere. In 2021, we did a video blog about TBO and said that the airline industry's future would be nuanced. Language is essential and points to why the primary user, and most definitely the primary beneficiary of TBO, the airlines, have found something more interesting to do this week. Has anyone caught the subtlety, although it's a little bit difficult to read? There are some glaring imperatives for doing this, and there are challenges underscoring the globalization of TBO. Most aren't technical. We think some tactical changes could improve momentum. So here's our quick five covering what we think are significant issues driving and hobbling the trajectory of TBO. The global airline industry has transformed the world. It's an indispensable part of modern life, essential to social and cultural connection, and vital to the planet's economic pulse. This industry punches above its weight. IATA's AGM announcement this week updated these numbers and estimates the industry delivers 10% of global economic activity. But its profits are an unsustainable 3% margin. Then we have some growing issues. In 2017, the London TMA reported it had its busiest day on record so far on the 27th of July. The press release covering the milestone contained some startling information that made the news for about a day. It warned the same number of flights could be cancelled every month by 2030 because of congestion, unless something was done. On July 24, 2019, Flight Radar 24 tracked 225,000 flights globally, recording the busiest day in aviation history and breaking NAT's previous record. Also in 2019, General Electric estimated that the industry binned 67 million meals, threw them out. Big arguments circled the globe between Geneva, Montreal and here, blaming ATC and particularly Eurocontrol for the delays weighing on airlines. But airline leadership was ignoring its own metrics. Was it because of the long-standing practice of file and forget? How is it the ANSP's fault when airline primary and reactionary delays outnumbered ATFM delays by better than 6 to 1? At the same time, airlines were doing everything they could to save a few drops of fuel here and there, relying on the multiplier effect to make the number look good, when a year's savings or more could be blown out the tailpipe in a morning's work because of inefficient arrivals and holding. Seeing $66 billion fly off the table because of system delays is troubling for a few reasons. Imagine adding some of that back to the bottom line. It wasn't a one-off. The numbers for 2023 were published a couple of weeks ago and are just as dire. So why is the airline industry not screaming from the rooftops for TBO? Then there's net zero. Most of you will recognise this. I want to concentrate on the green bit. It is stunning that our industry thinks that this paltry amount is all we're capable of. How it was determined is for another discussion, but it isn't nearly enough, and here's why. The Making Net Zero Aviation Possible is one of the better strategic documents about the industry's transition. It proposes a green premium for a just and equitable transition. The calculations are all there. They demonstrate that the transition will increase operating costs from 25 to 37% more than business as usual today. The document proposes that the industry needs to cover them by squeezing operational efficiency further. The alternative, passing it all to the customer, will smash demand and solve the problem for everybody in the wrong way. If this isn't enough, the estimated capital costs make the cost of COVID look like pocket change, which is why CAPA defines the net zero transition as an existential threat to the industry. Now we're looking more intensely at these, first highlighted at the Heathrow Big Green Day in 2010 in another one of those industry pronouncements that saw the airline folks in the room collectively turn pale. Ask me later. Other recent incidents will undoubtedly add urgency to the environmental pressures. Why does it matter? For almost 2 decades, the airline industry has failed to make its cost of capital, shredding economic value everywhere. Numbers out of the IATA AGM this week tell us that nothing's changed. Shouldn't all this be enough for airlines to act? The GATMOC was published in 2005, and the quotes from it and one of its counterparts are pretty clear, so you'd think. So what's the problem? Aircraft IT has its conference in Amsterdam this week, and Air Inc. and IATA have their EFB Users Forum in full swing across the pond. Collectively, almost 1,000 airline staff are there, basically shopping. Boeing will speak in Amsterdam about the EFB being the centerpiece of new digital flight decks, and we heard a little bit about that this morning. That's really good, but it could be really bad too. But by a ratio of almost 2 to 1, the suppliers there are touting profile optimization applications, and that's definitely bad. Picture the outcome. Aircraft pop up wanting random altitudes and speeds different from the plan, wanting something different a few minutes later when the app proposes something new because of a change in local wind or temperature. It doesn't end there, and thanks, Henk, for the graphic. In a perfect demonstration of the industry's silo principle, NASA has developed TAP and TASAR. These are EFB applications that propose track adjustment options to the pilots. And if more emphasis is needed, these guys have their own take. Loretta, part of the Flight Key suite, does vertical and horizontal profile analysis, bringing on-device trajectory optimization to the flight deck, not to the people in this building. OptiDirect from CETA does the same things in IATA in a convoluted reinforcement of a silo in a silo principle, is developing its, quote, own version of TBO, their words. These apps may eventually have a place in TBO, but right now they're an existential threat to it. A comment from one of the industry's better-known personalities reinforces the do-it-yourself approach, and I quote, "We should give up on the fly-what-you-file dogma and the idea of integrating FMS into modern ATM concepts." A few here will know from whom this quote originated, but reinforces the differing views of what people think TBO is. The airline industry has a long and lackluster record of project success because it takes a technology first, business second, and systems view somewhere down the road, if at all, to its change. Poor project doctrine has been a handbrake on outcomes and translated into monumental failures. This time it's different, perhaps. Most of the technology required to enable TBO is based on a set of robust information standards that are resilient, easily extensible, and simply translatable. The technology backbone for TBO and some implementation guidance has been around for a while. The EFB may be at the center of information management and communications on the flight deck. AIDs have made it a powerful tool. The combination of the FMC, AID, and EFB, coupled with the growing proliferation of high-speed data from Swift, Starlink, Iris, and a list of others, provide pathways to connecting the flight deck. A quick word about workload. I've been DARPed more times than I care to remember. The countdown to the DARP waypoint was one of the busiest times on the flight deck. Procedure requirements and technology limitations made it challenging. It worked sometimes, and it was debated often. There are 2 messages here. Get the flight deck involved early and understand that staying on the plan will probably deliver better outcomes most of the time. Ask me why later. For TBO to work, ingrained operating doctrines must be challenged. For all the focus on technology in recent discussions, and notwithstanding some machine learning and AI aspects, the interchange standards, service-oriented cloud architecture, data links, SWIM, and the enablers in section 4 of the global TBO concept are mostly match ready. That leaves global ATFM. Is that technology or something else? So here we are back at the beginning, and we think the crux of the matter. In their presentation, ICAO told the meeting that it viewed next-gen SASAR and SWIM as central to the concept and business case for the EFB, and the importance of it being highly integrated. Everyone missed it because the iPad loomed larger. This prophetic insight from the same group who often another silo was working with the FAA and EASA on DOC 120, designed to keep the EFB figuratively as far away from aircraft systems as possible. Over nearly 3 decades, the EFB has missed its reason for being. Airlines complicated the EFB to the point it took 27 years for a bright idea from one of the luminaries in that room to the beginning of its universal use on airline flight decks. The airline industry is fixated on committees for everything, undoubtedly to garner the broadest cross-section of opinion and expertise, you'd hope. Nevertheless, the overabundance of committees in the industry is a drag on results, and we wonder if its time has come. Waxing and waning support, a revolving door of membership, overlapping focus and changing imperatives because of poor business case direction, or none, cause 1 step forward, 2 step back progress taking years to deliver outcomes, well demonstrated by the 33 years it took the Digital Data Committee of the late 80s to get nowhere. Half a dozen airline committees were involved in the EFB's 27-year journey to fruition. 1 still exists, and it still meets. The industry needs to heed the lessons of the XM standards in a timeframe measured in years, not decades. The digital revolution is in overdrive. Without compromising safety, we've got to match it before the industry bolts off on another tangent. Taking TBO global or anywhere needs us to shift gears. The GATMOC, GAMP, and the manuals on SWIM and FFIS are detailed concepts that only take us so far, but don't connect the dots to the degree necessary to get the customer for all of this, the airlines, out of gadget conferences and into a strategic trajectory benefiting everybody. The vision for TBO has existed since 2005. It's time to turn the dial and develop implementation strategies and action plans for everyone, not just the industry's ANSP, SASAR and regulator segments. Enough airlines already think this is an ATC thing, and that's worrying at this point. Unless dialogue, direction and beneficial outcomes are modelled for all industry stakeholders to get a whole of system benefits perspective, the next time I hear someone talk about FFIS, the Flight Plan 2012 sunset date will have moved again. The critical challenge for globalisation is fragmentation, with too many different ideas about what TBO is and none about what is needed to make it work from a whole of industry perspective. This isn't or shouldn't be ATM versus the airlines. We need to corral the herd, and that means leadership. There's plenty on this side of the program. It's time for IATA to step up and represent, lead and serve its side of the industry. It's been done before. During the COVID crisis, IATA said in a few of their many webinars, coordination and harmonisation will be key to the industry's resilience and growth. It's time to set egos aside and for IATA to listen to their messaging and heed their mission statement. One of our customers explained why they didn't see this meeting as necessary. It sounds like we're being asked to drop everything and build a spaceship to Mars. We've got more short-term important things to deal with. Besides, it'll never happen. This attitude is at the root of the issue, getting airlines to recognise the critical contribution they must make toward their own survival. These are the challenges of taking TBO global or anywhere for that matter. Most aren't technological. Overcoming them requires guidance that expresses the entire system from all user perspectives, a view from which requirements and implementation plans can be derived. Reliance on suppliers and their top technology alone is a red herring. Ask me about that too. In a turtle versus the hare wake-up, the shipping industry has got the jump on us. And I quote, a ridiculously simple idea that cuts cargo ship emissions by more than 17%. It requires considerable connectivity, coordination and participation. Does that sound familiar? I'll leave you with this. If we build it, will they come? Thanks, Chris.
Thank you. Thank you, Michael. Wow. What a thought-provoking presentation, right? I wish we had 1,000 airline representatives here to listen to Michael. We hear some of still the risks, despite all the efforts that have been put into on the global level from different stakeholder perspective on even the regional and national level. We still have a risks of missing or making the similar mistakes that we've made in the past because of this silo approach, because of this disjointed efforts, having a different direction or different focus in even one part of the industry sector. Imagine if what we've heard is happening in different domains of an aviation. It's truly going to risk us bring the aviation industry moving forward to realize the TBO. So I think we've heard all different perspectives from the regulators and the ANSP implementers and the aerospace user implementers. So now we do have some pre-prepared questions, but I think you have a lot more questions that could be of more interest to you. So I'd like to open the floor for questions from you all. And as we did before in the previous session, please introduce yourself and where you're from, which organization. That will give us some more context on your question. So floor is yours. First one, yes.
Thank you. Ed Rosado, BAE Systems. We are a computer flight plan service provider. I was banging into the mic. I was very happy to see the joint presentation with CESAR and FAA. That's really good to see. My question, most of the flight plan service providers plan to meet the mandate for FFICE, the EFPL. What is the FAA's position? When will they be able to start accepting an EFPL type flight plan, FIXM 4.3?
So this is Luke with FAA, and right now the timeline is shown in the slides. We're targeting a 2028 timeframe to be ready to accept EFPLs in that new FIXM 4.3 format.
And any other questions? Okay, I have to be fair around the room. Okay.
In the same vein, hi, Scott Masarkey from Delta Airlines. I think that we have the easier task here with the EFPL mandate, but I'm curious, I've heard a number of airline ANSPs won't make that deadline. I'm curious if that deadline is still staying true of next year, if there are any ramifications for not meeting it, and if there's anything that's going on to help the ANSPs meet that mandate.
I can take that. We heard the question before. So we have now in Europe, we have set into motion an FFICE initiative where we work as a deployment manager together with NM, and we work with all the ANSPs trying to make a realistic plan, because it is clear to see that they will not all be ready to fulfill the mandate. However, it is linked often to system renovations or new system implementation of the ANSP. So they stand in a situation where often they have to decide, do we invest in a legacy versus a new one? And then the choice is often strategic and they go for a new one. In terms of infringement or punishment for not meeting the deadline, this is not something that we for SDM is enforcing, and it's something that the European Commission, but the legal deadline still stands. It's 31st of December 2025, with the consequences that could bring for those not complying.
Okay. Questions from this side of the room?
Hello, Zvonimir Šestan from the Croatian Civil Aviation Agency. I would just like to echo on what the colleague from the Delta Airlines said, that I'm not fully, I would say, compliant with what Mr. Molbeck said, is that the Commission hasn't been very benevolent regarding member states not achieving the prescribed deadlines for the CP1 targets. So I'm not sure if that is totally true for member states and NSPs in member states regarding targets for both FFIs and further developments of the TBO. And it's one of the concerns for the member states. So yeah, I would like also to raise a question. It hasn't been talked very much about the NSA role, the competent authority role. So if maybe colleagues from EASA or the deployment manager can give us some guidelines on how to behave. Thank you.
Perhaps Magnus or Brian?
Start and see if I need to.
Yeah, I'll start and see what Magnus has to say about that. An interesting question in that sense. I think these discussions have been going on for a number of years here in Europe, and shall we say this is meant to be a global symposium. This is a very European specific question and specific problem in that sense. The role of the member state, the role of the NSA is to ensure that the European regulation is implemented. Therefore, by saying that, the NAA should be overseeing the implementation and following the implementation of its overseen stakeholder. I'll leave it at that. Therefore, you should have a task to ensure that they comply. If they and take necessary actions with them, be whatever it is within your state, to ensure compliance. That action must be taken. If you don't take any action to ensure compliance, you are not in compliance with the conventions. So it needs to be done. You have a duty to ensure compliance, sure they meet the rules. That's basically what it is. In summary, there are lots of nuances to what I've said, but that's basically what is required from the NAAs overseeing their stakeholders to comply. It's not only applicable to the NSAs overseeing the ground systems. When we have a mandate, when we have the application to the aircraft, it's also applicable to those NAAs overseeing the operators that are flying in the airspace to ensure that they are compliant. And if they're not, they have to take the necessary actions to ensure compliance. And also, it goes with the foreign carriers flying into EU. They need to be compliant as well. And the NAAs need to take responsibility as well to ensure compliance. They have the responsibility. They must fulfill it. Should fulfill it. I won't say must. I'll come back to should. Okay, in that sense, it's a discussion that's been had many times, and I'm sure we will have that discussion. And I see my lawyer colleague over there nodding. This is a discussion that we'll have many more times with this subject.
Brian? Yes.
Yeah, Robert Winkelgren from DFS. I'm asking for a friend, a colleague which is online looking at the symposium. The question is to Lucas and Magnus. Does your group take care of the harmonization of the subscription mechanisms, which by the ICAO concepts are supposed to supersede the existing 8 FTN addressing? So to make sure that everybody gets the information they need and that all the addresses are provided properly. We had some issues. We as DFS, we are very closely working with Lido on the FFIs project. And so we had some issues finding the correct flight plans, which are relative for our systems sometimes.
Thank you for that question. I think I know who's online. But so I think it has been raised recently at a meeting in the FPFDE subgroup, and it's something that we are looking into together with DFS. I think it's not something that we can only take care of ourselves, and it's something that we need to deal with, but it's being looked into, and we will collaborate on it to ensure that also in a future environment, exchanging flight plans over SWIM, we will ensure that, of course, everybody who needs it gets the flight plan. And I guess that's all I can say about this one.
Thank you, Lucas. Maybe this side of the, okay.
Yeah, hi, Pete Salty, Eurocontrol. Michael, that was one hell of a presentation. And I appreciate that you came a long way to deliver that speech, okay? I mean, who do you think really needs to step up to be a champion, a leader, to make this thing really work? Because you mentioned lots and lots of committees, but in my experience, you need kind of champions to make things go forward, yeah? So who do you think needs to step up?
I agree with you about champions, and the committee system hasn't served us well for a long time. There are too many moving pieces, and too many people come and go for all the reasons I talked about. I think the Eurocontrol ICAO group that has developed a concept for TBO and all of the constituent bits that we've heard about over the last couple of days, they're pretty well led. I think some of those groups are potentially a bit fragmented, but the airline industry is really the biggest beneficiary out of this. And at the moment, there are a few airlines in the room. I don't know exactly how many, but it's nowhere near the numbers of the folks that are up looking at toys. And I think the penultimate group that looks after airlines is IATA. Unfortunately, at the moment, we've talked to them over a number of years, and in terms of getting them to step up to the plate. Unfortunately, they have different views at the moment about what TBO really is. But I think if we can sort that out, and I had a conversation with Giancarlo yesterday, which was enlightening to the point that they have a different view over here to what they have over in Montreal. And if we can get all that together, I think IATA leading that part and putting those airline side implementation descriptions together, that they've got to be the champion. It can't be Eurocontrol, because airlines see their ANSPs and their regulators as sometimes the enemy. But it's what IATA was constituted to do.
Thank you. Maybe this side of the room again. Go ahead.
Yes, Bruno Talavera from ENAC, the French Civil Aviation University. It's a question more about SWIM, not really FFIs, but about SWIM, and probably to Magnus and Lucas. So in a context where demand, digital NOTAM, last minute meteo, last minute updates about capacity disruption can be directly uplinked through the EFB. Is there, as long as information is available through SWIM services on the ground, is there still a need for air-ground SWIM?
I can try to. This is an interesting thing. So luckily we have some R&D, his colleagues in the room also. So it all depends, I would say. So I think there are many who believe that there is a need for SWIM, air-ground SWIM, and I think it's in the ICAO documents, and we also have R&D going on with it in Europe. But there are many means to get the information to the cockpit. There are the means that you go get it through the FOC, etc. But I think the plan is still, as far as I understand, that we are looking into, for an R&D perspective still, air-ground SWIM, for the reason that then are told in the document, especially the needs of airspace users. But again, the information can be received and communicated to the cockpit in many ways, for sure. I don't know if you have something to add.
Yeah, the only thing I would add is that I know with the FAA, we also have some R&D activities around air-ground SWIM, and I think everybody knows that my phone friend colleague is here sitting in the back as well for Mr. Bradford. If there's specific questions, he might be a better place to get the answers on those R&D projects.
Thank you. If I may add, also on the ICAO level, the air-ground SWIM in the context of the connected aircraft concept is also being looked at, A, to mature the concept, B, to identify the areas for the global standardization. Then I get to ask a question that I've prepared. Who do we ask? Maybe to any panelists. When we talk about the global interoperability, especially the global standardization, it is always a challenge what level of prescription or what level of performance-based requirements. So it is always a great challenge to strike the right balance between the uniformity and flexibility in the requirements. So does anyone have any thought how we can do a better job in making sure the right level of requirements are in place?
Maybe I'll have a first stab at that question. There has been, and there is continuing being, a very big debate and very big question about performance requirements and everything going performance based. We need performance requirements to make sure we go forward. Yeah. I think this is what's behind your question in that sense. But performance requirements only take us so far. They define how the concept, how the operations, and what the performance of the operations will be. They will define what maybe the performance of a link should be. Yeah? But they don't tell us how to make it interoperable. So if you want to meet those performance requirements and you want to be interoperable, so everybody's talking the same language, you need to come down to, I would say, prescriptive standards. They need to be prescriptive. Everybody must comply with a prescriptive interoperable way of working. So the whole suite from performance all the way down to prescriptive is needed and needs to be implemented into the frameworks to make sure they're overseen and implemented correctly, to make sure that operations such as TBO, and this goes for other operations as well, this statement, can go ahead on a regional and global basis. If we want to try, as we talked about, data sharing between regions, between NSPs, if we're not interoperable, if we don't share data in the same format over the same network or network which are compatible in that sense, we will not get where we want to be. Data, it has to be the same. It has to be interoperable. I will leave my statement at that and see if Magnus wants to maybe add anything.
Yeah, I have a view on it also, maybe slightly different perspective, especially if you take swim as the example. I think this is what we all look at. It very much depends on what constellation we're looking at. So do we have one provider? If it's one provider of a service, then the standardization need are probably less important than of multiple providers. We're looking into, as we are overseeing the implementation of CP1, ensuring its harmonized implementation. We have a deployment family of Meteo swim implementation. And where we're looking at an environment where each country have multiple med providers, potentially all mandated in each country. So we're looking at an absolute nightmare if we will see that each user of Meteo information needs to consume from each single one of these providers. If we don't standardize, if we don't ensure this harmonization, then the users will absolutely not be able to get consistent weather information at a European level. And therefore, we always need to strike the balance here. We also have stakeholders who really are wishing for strict implementation guidelines, where others are saying, we can do this and we will ensure it ourselves. So it's a very difficult balance to have. And this is what we're trying to, as SDM, ensure in Europe together with the actors, at least. Yeah.
Thank you, Lucas. So I think I slightly went over a little our time allocated to this session. So I think it's time to conclude. We've heard from different perspectives that we still have challenges ahead of us, although there are a lot of work that has been already put into place. But how we're going to bring this TBO more global is, what I hear is we really need pool our resources and align our efforts together to identify the clear objectives that will actually bring the values to the specific operation or specific operational environment. And another aspect that we heard is to do that, we really need to have clear standards that strikes the right balance between the performance-based and also prescriptive approach. In doing so, yes, I know you all look into ICAO. ICAO can do it all. So ICAO and the other standard making organizations also have to pull our resources together to make sure that all layers of standards are in place to ensure the global interoperability. With that, I would like to thank all of you for your active engagement and participation, and also like to invite you to applaud, a round of applause to our guest speakers on our panel.
Thank you very much, Crystal, and thank you to the panelists. So this brings us to our lunch break. So the lunch will be served outside in the lobby of the Europa Room where we've been having coffee. We will resume this afternoon at 2:15, so you've got time to relax a little. For those of you who are taking the next tour of the Network Manager Operations Center, that will be at 1 o'clock. I think the meeting point is marked outside in the lobby near the exit of the lobby area. I remind you once again, we have the exhibition available for you. And with that, please enjoy your lunch and look forward to seeing you back at 2:15. Thank you. Good afternoon and welcome back for the second afternoon of the Global TBO Symposium. And welcome back also to our online participants. So this afternoon we have two sessions, and the first one this afternoon we've been concrete already, but we're going to get very concrete now. And we're going to have a session looking at progress on TBO implementation. And for that, it's my great pleasure to introduce back Razvan Bucarayo, the head of the Airspace and Capacity Division in Eurocontrol, who will moderate this session. Razvan.
Thank you very much, David, and good afternoon again to everybody. A lot has been discussed over the first half of the symposium on the concept, on the evolutions, on what is in the pipeline in terms of research and development. But let's talk now about how we started the implementation of the trajectory-based operations concept. And here in Europe, we have quite an excellent experience already with the implementation of the trajectory-based operations concept, not only through the implementation of the FFI's Release 1, but also through the implementation together with ANSPs and airspace users of some initial steps concerning the implementation of the other elements of the trajectory-based operations. I'm very pleased to introduce to you the speakers of this session. The first one is Augustin Gheorghe. Augustin is Senior ATM Expert in the Airspace and Capacity Division, and he was, if I can dare to say so, the Mr. FFI's Release 1 implementation. He knows a little bit everything about what has been done. The next one will be Enis Aksu. He is captain with Lufthansa. He has been involved in a number of trials that have been run between Lufthansa and one of the major air navigation service providers, the Eurocontrol Maastricht Upper Area Control Center, and he will share his experience on that with us, but also a little bit on how Lufthansa, the Lufthansa Group, and the supporting computer flight plan service provider enable the implementation of FFIs. And last but not least, Peter Hendricks, who is the head of the ATM development unit in the Eurocontrol Maastricht Upper Area Control Center, sharing their first experiences with trajectory-based operations, what this meant in terms of development, but also operational performance for Maastricht. So we will hear quite interesting, tangible experiences. I don't want to take more from your time. Augustin, you are the first one introducing to us how the FFI's Release 1 was implemented in the network management systems. Augustin.
Good afternoon, everybody. Thank you for the introduction, Razvan. I think I'd like to say that I'm not really the Mr. FFI's implementation, because Mr. FFI's implementation has retired in the meantime. And I refer here to my former colleague, Kim Breivik. I think he would be the real Mr. FFI's. So I'll talk to you about our implementation and implementation of FFIs. But I will start, well, until now you've heard quite a lot of variations and options and explanations regarding what TBO is. So I think it's about time that I talk to you about what FFIs is. You heard a little bit from Magnus just before lunch, but I'll put some more details about what FFIs is. First of all, it stands for Flight and Flow Information for a Collaborative Environment, and every single word in this title is important. It is collaborative environment, it's not cooperative environment, and that makes a difference. And it is an ICAO concept that's been developed by ATM RPP, more precisely. It is the foundation of TBO, and it also introduces a modern flight plan that will replace Flight Plan 2012, that will provide for an increased information sharing, information that is highly structured and digitalized, And it comes with a standard format that is maintained and agreed at the global level. And probably last but not least, it makes use of SWIM information services. So in other words, just to put back the buzzwords of TBO that we've seen yesterday, FFIs is about sharing, maintaining, and using flight information. And this is the essence of TBO. Now, next, about our implementation. Well, we have here the NM area. In our role of European network manager, we exchange flight information with ANSPs across Europe and beyond to improve traffic flows, to enhance traffic predictability, and ultimately to increase network capacity. Now, together with our partners and stakeholders, we develop and implement solutions to meet current but also future needs of the European ATM. And FFI's implementation is part of such development. Now, the journey of FFI's implementation started back in 2015 with the creation of the network strategic project, which is called Flight Plan Flight Data Evolution. This seems to give a problem to everybody who tries to remember this FPFDE acronym. But it is the network strategic project that was established in 2015. The project developed his first implementation strategy 1 year later in 2016, and a dedicated task force was put in place at the initiative of the NetOps, a task force taking care of practical implemented flight planning solutions. Now, nowadays, the task force has been elevated to the subgroup level in recognition of its permanent nature of work. Actual FFI's implementation started in 2018 with the initial filing and trial services implementation, and also the provision of the evaluation feedback back by NM. And is continued with a stepped progression. In 2019, flight data request service was implemented, but also re-evaluation feedback. 2020, the publication service, and 2021, the notification service. All the efforts culminated in December 2022, when we moved to operational use, when we had the first EFPL submitted to the operational system, and our operational system submitted by Lufthansa, making use of the Lido Flight 4D system. So all in all, I think we can clearly say that we have implemented in NM all the FFI services that were defined and developed by ICAO, all but one. And that one, you will hear from me a little bit later about it. It's the planning service. Now, very briefly, this is just to show you the level of daily EFPLs that we received in the past 1 month. It's probably not a lot, but I could have presented monthly. Therefore, you would have get a little bit bigger number than what you can get as an average around 80, 90 flights per day. Okay, flight plan. So with the implementation of FFIs, we effectively move from the text-based flight plan 2012 with its limited amount of information. We move from that into FFI's flight plan, the EFPL, with its containing substantially more details and a higher granularity of flight information. For example, you have flight specific performance data. You have 4D trajectory. And I like to highlight that the 4D trajectory is not a simple ordered list of 4D points, but it comes with additional information that is attached to individual 4D point information that provides properties like top of climb, top of descent, trajectory change point, and so on and so forth. So effectively means that the EFPL provides a detailed view on what the airspace user plans for the flight to do. Now, we as NM, we use this information, and return back the feedback from ATM, which contains, in most of the cases, additional constraints. And those are also identified to trajectory point properties, like constraint points. So this is an information that it's nowadays not provided through Flightplan 2012. So this is already a progression. It's additional information that is shared with the airspace users. The information inside the FPL, it's highly structured and digitalized. And as such, it is much more appropriate for a machine to read than for a human. As you can see there on the right-hand side, the blue text is not only that it's small, but I tell you, even if it's big, it's not for human consumption. And however, this translates in an opportunity for more and more machine-to-machine automatic exchanges. So we were talking in TBO about automation as well. So yesterday was touched upon. And our last bubble here, it's about the standard. The standard that we used, what the FFIs is using in terms of data model, it's called FIXM. It's Flight Information Exchange Model. So we have integrated in NM, we have integrated the services in the NM B2B, which is a SWIM compliant infrastructure, making use of both request reply and publish subscribe communication models. We support today FIXM 4.3, but also FIXM 4.2. However, the later will be decommissioned by the end of the year. And this is in line with the NM B2B policy. Our implementation follows closely the ICAO implementation guidance, while taking into consideration the specificities of European operations. And last but not least, the feedback returned by NM in response to the submission of an EFPL does not include the flow management measures, the impact on the flight, and this is yet to be defined by ICAO for a subsequent inclusion in FIXM data model. Now, together with FFIs, we have put in place additional processes. Some of them we are already doing with the Flightplan 2012. You can see them as services, but they're not at the same level of the of an FFI service. So to be wary about the time, shit, I forgot about that. Sorry, I'll try to speed up a little bit. So we have the translation service. With this, NM automatically translates FFI's flight plans into Flightplan 2012 for the ANSPs inside the NM area of operations, ANSPs that are not yet migrated to FFIs. Now, the next one is reevaluation, and this is quite an important one. This is equivalent of the revalidation that is done today for Flightplan 2012. And it is a process that ensures the flight data is maintained compliant to the updated ATM constraints and restrictions. And the last on the list is translation and delivery. And with this one, the airspace user for the flights going outside NM area can request NM to translate an EFPL to Flightplan 2012 and have it delivered to identified non-FFIs capable ANSPs that are outside NM area. Okay. A little bit about the mixed mode and transition operations. Well, with this is quite a complex subject. I can tell you that we've put in place comprehensive arrangements to cater for the transition period during which mixed mode operations will be in place. I will not go through the details of the schema, not only that I have completely eaten my time, but also because it's very complex. But just high level, you can see here that we are translating, as I said, EFPLs to Flightplan 2012. But you can also see that we're converting FPL to FIXM. And this is, I'd really like to highlight that this is just a format change and not a change of the applicable procedures. Now, why we do this? Because we try to facilitate the migration from AFTN to SWIM compliant technologies for our European ANSPs. In terms of further developments, very, very quickly, we're looking into implementing the planning service with the preliminary flight plan, which is still part of the FFI's release 1. But we also look into FFI's release 2, which is effectively an extension of the flight planning into post-departure operations. Okay, this is, as you have heard yesterday from Gerard, these are all tackled under the CESAR Network TBO project. Now, this is a list of documents that will give you further implementation details. I have forgotten to add the translation and the transition and mixed mode operation document. Sorry for that, but that's yet another document that is available for you. And this is it. I conclude my presentation here. I, however, want to leave you not only with our details, well, details of our implementation, but I think it's important to share with you that what I think FFI brings to flight planning is very much similar to what radar has brought in the past to air traffic control. So you simply start seeing things that were not visible in the past. Thank you.
Many thanks, Augustine. And of course, after we will hear the 3 presentation, we will start a little bit of discussion and some further questions to Augustine. But now, without any delay, Anis, the floor is yours to present the Lufthansa experience with trajectory-based operations and FFIs. Anis, please.
Thank you, Razvan. Thank you, Augustine, and thank you all for being here and joining us to this really challenging and interesting topic to explore the crucial role of trajectory-based operation and its significant impact on reducing CO2 emissions. I'm very happy to present today the progress of TBO implementation within the Lufthansa Group and show you some initial benefits we are starting to experience and also gave some future outlook. I'm sorry, I have to bother you a little bit on, just give me here, yes, on the topics we have already been talking since yesterday, but I will just quickly go through to the highlights so we can jump to the main important topics about what we are doing on TBO. So TBO for us, we already know this, is the fundamental pillar of ATM and to promote more efficient, sustainable, and safety in aviation. And we cannot repeat this often enough. Main important thing is it involves the collaboration effort of all key actors, namely the ANSPs, the airspace users, and network manager. And TBO goes through all phases of flight, so it starts with pre-flight planning until to the post-flight. Also, the benefits we have seen many times. I just sum up the key benefits, the potential benefits. It's a capacity, increasing of capacity by optimizing airspace usage. We have expect more efficiency by precise trajectory management, sustainability by reducing CO2 through optimal flight routings, and of course, increase of safety because of enhanced situational awareness. Now, coming to the Lufthansa Group, for us, 2 prerequisites or building blocks are essential for a successful implementation of TBO, which is first, ATSB2. We have heard this also the last 2 days with the components of ADCPP and CPDLC, and of course, FFIs, which Augustine was presenting before. The Lufthansa Group has been proactive in adopting the principles of TBO, and for this we started with early investment of ATSB2 and early implementation of FFIs. And with this decision, we are improving our operational efficiency and sustainability But to unlock all the benefits, all 4 benefits, needs more work to do. And I will address this later on the next slides. One slide here shows our progress regarding the implementation of FFIs. We already know what's behind FFIs, so it's the sharing of 4D trajectories with flight planning systems, and we also know that the I'm sorry, I just yeah, I just switched next slide. Sorry. And on the bottom, you can see the timeline, what we have achieved so far. So we started with the development in 2017, and then the first operation flight plan was sent in 2022 to the NM. And today we are sharing around about 50 to 100 flight plans of scheduled flights with NM. And we are expecting to be operational in 2025, which is the target date for the mandate. There's still some open issues to be clarified and be worked on it. Some gray zones, mainly concerning the technical operational questions, but these mainly this resolution of which is necessary for smooth implementation. So the main message is that it's crucial that these open points don't slow down the implementation process and everybody sticks to the target gates. We have done our homework. We are ready for operation in 2025. But so far, we aren't experiencing any benefits. Even we are sending flight plans to the NM because for gaining and generating the benefits, all stakeholders must be involved and everybody has to stick to the target gates. I'm going to the next page where I would like to give you an overview over the activities on ATSB2. If you look at the current situation, and we already talked about this as well, Maastricht is the only ATC unit that has been operating ATSB2 since 2022. And we were talking to Maastricht and trying to focus on 3 use cases according to the traffic flows that would bring us benefits according to our traffic flows. And for that, we focus on, as I said, 3 use cases, and some of them were already mentioned before. First one is the later start of descent, which is clearly to keep the aircraft longer on the en route altitude and clear it for descent on the optimum point, which is sent by the flight management system to the controllers. The second one was the earlier direct routings in the climb phase. So the controller knows the precise prediction of the top of climb and can assure earlier clearances, shortcuts, and avoid delay vectors, etc. And the second one is the better en route delay absorption just by assigning precise speed restrictions instead of blank speed reductions. And with the assistance of the controller's assessment and according to the application rate, we developed savings for each of these use cases just according to the traffic flows of our flights going through the Newark airspace, which you can see here. We had in average 14 kilograms of fuel savings just using the first use case and 4 kilograms on the next 2 use cases. Based on these insights, the Lufthansa Group decided to start equipping new aircrafts beginning this year, 2024, just ahead of the mandate, which is 2028. And this brings us to the next point, because now we have been delivered already the first aircraft equipped with EDS EPP, and we are able to look if the benefits we're talking about, if they're really achievable and feasible. So last week we did the first trial, the first live trial with an aircraft of Brussels Airlines equipped with EPP, flying from Copenhagen to Brussels. And here you have a screenshot of the controller working position of Maastricht. And on the right bottom, you see the EPP information, maybe very interesting for you to see, the waypoints and also the top of climb information. And just with this information on this flight, the controller was able, according to the information given here in magenta, the top of descent information, the controller was able to clear the aircraft 3 minutes later for descent, which brings us a saving of, in this case, 22 kilograms of fueling. We also had some shortcuts gained by, which was achievable just due to the information which was given by EPP, but this is just one example. So we could show that the potentials we were analyzing before are achievable and feasible. So I'm running out of time, so I'm just getting a little bit quick on this. We would like to show you that the technology alone does not bring the benefits. So we have to go through the process that we have to invest first in ground and air systems to enable the benefits. And then we have to define the benefits by use cases, which we already done. And then we have to train pilots, controllers to realize the benefits, use cases, and what we did on this flight trial. So we realized locally benefits. But now comes the last step, the important step, which brings us to the global, to generate the global benefits by defining harmonization and synchronization all over the stakeholders. Two more slides. This one, on this slide, I would like to show that early investments pays off, because I compared two scenarios on this slide. First scenario is starting with equipage today. So in 2024, starting with equipage means we have 65 aircrafts being delivered at the mandate date in 2028. So we will start with the full usage of ATS EPP with all ANSPs in 2028 with 65 aircrafts. So the yellow accumulated savings shows how the savings will go till 2032. And the second scenario would show that we do nothing now today and start equipage with a mandate date in 2028. And then we will have to first start with the ramp up of the equipage rate. And this would show the light yellow graphs here, which we would lose a lot of savings. So this is the message to all of you to start earlier than the mandate date to generate more savings than to wait until 2028. And my last slide, just to give an overview and conclusions on what I've already said. First one, we are seeking to motivate partners to join us for new use cases. So you're happy to contact us for working on these topics and generating benefits today and not in 2028. Full ATSB line 2 is not mandated by CP1. So this is also important. CPDLC version 2 is not within the mandate, but we saw that it's crucial to have it together with ATSB2. And the third point was already said before, we are facing a critical bottleneck with the bandwidth, and we need to work on increasing the bandwidth beyond today's level. The next point is very important. We all have to stick to the timelines. Otherwise, we will not get the benefits. And the last point is regarding FFIs. here is really important that we have to stick on the mandates, on the target dates, and not allow to slow down the implementation speed. So that's it from my side. Thank you for listening. And questions?
Many thanks, Enis, first of all, for the good experience, for indicating the operational benefits and the possible savings, but also some very clear requests from the airline community in which direction we should go. And without any delay, we move now to Peter Hendricks, Head of ATM Development at the Maastricht Upper Area Control Center. And Peter will present to us what they have done on the ground side in order for Lufthansa to benefit from what we have just seen. Peter, go ahead. And don't worry about the delay. This does not reflect the delay savings that the TBO will bring to us. We are fine.
Good afternoon, ladies and gentlemen, and thanks for giving the opportunity indeed to show you what we have done already in Maastricht regarding TPO, starting in particular with ADSC. A small overview of our data link history. We started quite early in the 90s already, actually, with data link with CPDLC. Then we went in Cesar for this trial of the I4D flight, where we were flying to time constraints. As was mentioned yesterday, that was not so successful. But then we moved on into the ATS-B2 exploration in Cesar 2020, where we, together with Airbus, looked at implementing ADSC and downlinking the EPP. 2019, we went pre-operational with the downlink of the EPP and CPDLC V2. And after 2.5 years, in May 2022, we went fully operational with ADSC and CPDLC V2. The mandate is by 2027, but it doesn't mean that we will sit still that time. Between now and 2027, we will look for improvements in our HMI still. As I will show you, we're not using all the data yet, because we first need to analyze the data, see the quality of the data, and then see how it can be integrated in our tools. So all this work will evolve over the next 5 years in order to make the system better. What do we have implemented? First of all, the EPP is downlinked and then displayed to the ATCO. And then what we do is we don't use the EPP directly and say, this is now our new trajectory. We have a trajectory on the ground, we receive the EPP, and to the ATCO, we will indicate whether there are discrepancies. So this is a first application, is to detect, is the air synchronized with what the plan we have on the ground. Second application, and it was mentioned by Enis, is the top of descent and the top of climb. And those two can be used to really enhance the efficiency of handling those specific flights, as I will show you soon. And the third application is the time of arrival. So via ADSC, you can ask the aircraft, okay, at this point, what's the earliest time you can be there? Or what is the latest time you can be there? And then you get to a time window downlinked for you to make decisions on that. What are the benefits? The major benefit for the ATCOs is the safety improvement. You take away doubt. By downlinking what is in the FMS, you actually know what the aircraft is going to do, and you don't have to monitor anymore in case there are critical maneuvers. You just know, hey, this is what's going to happen, and the aircraft is also planning to do this. So mentally, for the ATCO, this is really a reduction of effort, and it improves the workload, which has a consequence, we hope then, that it can handle more traffic, of course. You know this picture, it was just shown by Enis as well. When we have the top of descent, we will try to endeavor that the flight can start descending at the top of descent as contained in the FMS. And there you see typically, okay, where you would give a clearance to descend at 1500 feet per minute. You can tell the aircraft descent when ready. And then the pilot can optimize the flight and descend at the best, start descending at the best top of descent. In the little drawing there on the bottom, you see actually that 30% of the descent clearances that are uplinked today are uplinked with descent when ready, which is quite substantial. Some figures mentioned already as well, how many fuel has been saved by applying this technique. The application of time of arrival is useful in this example. If you have a military area going active, you have a flight heading towards it, or has to go in that direction, where you would give it a shortcut if that area is not active. But if it's about to become active, you can then ask the aircraft, okay, what is the time you will be able to leave this area? So in this example, you see that at the point Juist, the aircraft will be able to be there at 9:53. So leaving the area at 9:53. The area goes active at 9:55. So there you can say, okay, the aircraft will make it, and you send them through the TRA that is about to become active. This gives, of course, savings in distance. And there you see also some figures. If you can shortcut 5 nautical miles, it's already substantial fuel saving that you can achieve. The more efficiency, and here it's a combination of ADS-C with CPDLC V2. The nicest thing about CPDLC V2 is that you can uplink LOT longs. So you can always uplink a closed trajectory using LOT longs. And in the aircraft, there is the load functionality. So to avoid mistakes by the pilot in typing in the LOT long, now the pilot can just load it via one selection on the panel. Here you see, for example, an area we need to protect, which is there in the northwest of the picture. Normally, the flight will go through a published point, REDFA, no, TACA here. But actually, because we can uplink the LOT long, we just make it go closer to the area that is protected. And by that, we save substantial nautical miles distance. So what are the benefits for us? As I mentioned, it is really a safety enhancement, a mental workload reduction to have the EPP downlinked. We can improve efficiency in both the vertical plane and the horizontal plane. And it allows also, once that there will be more equipage, to have a better traffic management within the center and within your sectors. The benefits for the other actors are listed here as well. I will not go into those details. Future, what are we looking at for the future? We hope that the Meteo models in the FMSs will be improved. There is inaccuracy in the timings and in the performance of the EPP, some inaccuracy, and we hope that can be improved by using better Meteo data. We also think that the EPP, once it's used in lower airspace, it can considerably enhance the AMON predictions. And not last, but quite important for us as well, is that ATS-B2, by downlinking more data from the aircraft, we will be able to automate easier. So ATS-B2 will allow us to automatically, in the future, I'm now talking, let the system give clearances. And by downlinking the EPP, or by downlinking the frequency, the selected frequency, which also is part of the ATS-B2 baseline, you can actually see or make sure that what you have instructed the aircraft to do is now implemented inside the cockpit. And as has been said multiple times, it is of course one of the enablers for trajectory-based operation. Another element we are working on for trajectory-based operations is FFI's Release 1 implementation. We are currently making the implementation plan. It's under construction. The call for tender has gone out to industry. And what we commit to is that we will have a full EFPL in fixum format processed by the FDPS by 26, 27 timeframe. So we're not going to make a translator or something that converts the EFPL back into an FPL and then inject it into our FDPS. We're going to really modify the FDPS so that the EFPL is digested by the FDPS himself. What are the expected benefits of the EFPL? There will be more data available. That's the good thing. But we don't know yet exactly how we will use this data. All this depends on the quality. This is data coming from the planning phase. So how accurate will the data be in the EFPL? We don't know yet. And depending on the accuracy, we will decide what to do with it. Either to use it directly in our trajectory prediction, if it's really good, or maybe use it more for display purposes for the ALTCO in order to help him to decide things. What does it also bring is that we are looking actually to some services that are not part of the FFI's Release 1 package now, but there are some services that are coming, like the consolidated feedback service that we are really interested in and be more involved in. Another element we still hope to get through FFIs is the unconstrained desired trajectory of the airline operator. Because if we have that, we can always try, even in the tactical phase, to stick closer to it and to improve our service. And last but not least, by doing Release 1, we hope to be prepared for Release 2. In Release 2, we will be more involved. The local management, the local flow management will be involved there in a negotiation with NM and with the airline operators, or with the airline operators through NM. And we hope that Release 1 implementation will ease the Release 2 implementation. As mentioned by Gerard, this is subject of the CESAR network TBO project, in which we are involved as well. In 0 seconds, I thank you for your attention.
Many thanks, Peter, and that demonstrates also the very good operational performance of Maastricht, meeting exactly the target. Thank you very much, Peter. There were 3 very interesting presentations, and before starting with some questions from the floor, I would like myself to initiate some discussions. First of all, for Augustin. Augustin, which were the tricks and challenges that you had and our ex-colleague Kim Breivik, to remember him also, you had with the implementation of the FFI's Release 1 in the NM systems?
Okay. Thank you for the question. I think there are a couple of things that probably should be mentioned here as important, playing an important role in our implementation. One would be to manage to attract important stakeholders, or the main players, should I say. We've been quite successful, but I have to say we also had collaboration with Lido before FFI's implementation through CESAR projects, the extended flight plan, but that was very, very helpful to have that. And probably an important trick and development that we had put in place is the special way and the arrangements we have had with the CFSPs and the system we put in place to allow them to test while developing. And that was helpful on one hand for them, but also for us, because we could have seen what was wrong, or either on their side or on our side. So we knew what needed to be corrected. So I think this is the main points I could refer to.
Many thanks, and important from this, you saw that the presentation, the implementation was basically done more or less over the period of 4 to 5 years until it was completed. So it was done in steps, and we are also allowing the possibility to further evolve as it comes, while at the same time ensuring that the mixed mode operation continues until everybody is ready with the implementation. Now moving to the airline experience, Ennis. First of all, how easy we have seen those changes, and to prepare for those next steps of the trajectory-based operations, and which were the challenges for you and for your computer flight plan service provider to implement FFIs? We've seen already quite a relatively good number of flight plans coming from Lufthansa Group, and I must say that Lufthansa Group, together with Lufthansa Group, with Lido, we have done quite extensive testing and learning process on what actually FFI's flight planning means. Ennis.
Thank you. Thank you very much. To your first question, first of all, we had to find out if the use case or if the benefit which was promoted for HSP2 is achievable in our company. So that was the first challenge. So we were working for many months together with Maastricht and the experts, controller experts, to see which use cases really are applicable for our traffic flow, because it's really dependent of the traffic flows. For some airlines, for instance, which don't have that much vertical traffic in Maastricht, it doesn't bring a lot of benefits, because for us, just a lot of the benefits are achievable by the vertical flight phases. So that was the challenge, and we did our homework, and we could determine some potentials. And as I showed before, the flight trials showed that the potentials were real, achievable and feasible. And we're really happy to have this showed to you today, because it was not easy to organize this. And coming to your second question regarding FFIs, well, this was an iterative and collaborative work, because always when you come with new standards, new formats, you have to have a lot of exchanges to find out the crucial points, but we are today at the phase where we are sending 50 to 100 IFPLs. And as I've said, there are still some open issues which needs to be clarified, but we are working on it. And we are hoping that we can solve all these open issues till 2025.
Thank you very much, Ennis. And there are indeed always some challenges. This is why it is very important to start early the testing, to be able to address everything that might still need to be fixed. But I will come at the end of this session a little bit on this one, on some sort of promotional exercise, but it will be a little bit more than that. Peter, from an air navigation service provider point of view, we have seen what you have done. We have seen the benefits. What were the important things for you in this implementation? And what you will see next as a very important requirement from your side in terms of continuing the implementation of TBO?
Okay, developing systems for ATCOs, one of the challenges we had was to, well, technically to get data downloaded from the aircraft to the ground, but also to have the right HMI for the ATCO. It has to be intuitive. It cannot overwhelm the ATCO, because it's, again, additional information that you're showing. So we really took our time to develop an HMI that is helping the ATCO in taking decisions, that is grabbing his attention to the right things, that is helping to populate menus so that his inputs are made much easier. So there's a technical challenge of the downlink itself, but then there was the operational challenge to come up with an HMI that allowed to use the system. Next steps. Okay, of course, we're very happy that AF6 eventually passed the maturity gate and that it will go on and will be implemented. The concern we still have there is that people maybe don't realize fully that the biggest benefits of ADSC come together with CPDLC V2. So our plea is don't implement only the EPP of B2, but please go for the full package so that the benefits for the airspace users can be fully exploited. Another concern is exemptions. We hope we will not get a list of 50% of the aircraft are exempted to implement the EPP. And then I would also say, okay, everybody is allowed to reinvent the wheel, but if you don't want to reinvent the wheel, I tell everybody to join the Ops Excellence program for Data Link, where actually we are feeding all our inputs. And I think if you want to learn something, go to the Ops Excellence program to get information, or visit Maastricht. We will show you on the screen.
Many thanks, Peter. So a couple of interesting messages. First of all, CPDLC V2 is the way to go if we want to see those benefits. And on the first day, we are presenting what this could mean in terms of benefits network-wide. And fortunately, our colleagues in Maastricht are very, very close to that. But the benefits are quite significant. So the next steps need to be in that direction. Also, please do not reinvent the wheel. Please do not, there is a lot of best practice that is available through the Ops Excellence program in the data link, but also in other work streams and topics of the Ops Excellence program. Do not reinvent the wheel. Use the existing technology, use the opportunities to implement this and make sure that the benefits can be gained very, very quickly. Because on longer term dreams, I'm afraid we will not be able to wait for such a long time. Now, before I open for questions, I've said that I will make a little bit of publicity because this is a global symposium and because we are talking about the trajectory-based operations implementation, FFI's Release 1 is the first step. And FFI's Release 1, as you have heard, has been implemented in the network management systems, and it is progressing in its implementation with the airspace users, computer flight plan service providers, and the air navigation service providers. And because this is a global symposium, I would like to make this global announcement that yet is to come via more formal ways and means, either through an aeronautical information circular or later on this year or earlier next year through an amendment to Doc 7030, that FFI's EFPL is mandated in Europe as from 31st of December 2025. So all the European Union member states, plus Norway and Switzerland, will have to implement this as from 31st of December 2025. So any airspace users of the airspace of those states will have to file an EFPL as from this date. As informed by Augustin, we will have some transitional arrangements for those who will not be necessarily fully ready by that date, but this will be the mandated date for the European region. So basically, it will be the first region in the world mandating the implementation of FFI's Release 1. So for the airspace users that are not located in the EU member states, this is a very important information to be taken into account, but it will be more formally announced. Now, open to any further questions that you might have to our NM colleagues, to Lufthansa colleague, or to the Maastricht colleague. Yes, please.
Thank you very much. I'm Soufiane Moumtaz. I'm air traffic controller from Morocco. So from ATC point of view, I have two questions, please. First one is a general question. What do you think should be included in ATC system in order to comply with the new requirement maybe in the future for a TBO concept? Second one is specific. It is related with another concept, which is the free route airspace. We know that there is this concept in many ACCs. Also, it is included in Morocco. What is the point between the link maybe between concept of free route airspace and TBO? Is it substitution or improvement, or it should be collaboration between the two concepts? And thank you very much.
So the first question was about the upgrades that need to be made to the flight data processing system, and then the relationship between the free route airspace and TBO implementation. Who wants to take the question on the flight data processing systems? Peter?
Okay, I can take that question. What we had to do in our ATC system, because it's not only FDPS, but of course you need to upgrade your front-end processor to be able to get the data inside your center from ARINC or from SITA. Then it depends how far you want to go. At this moment, as was mentioned, we're only comparing the EPP with the trajectory that we have on the ground. So there you ingest the EPP and compare it. And as I mentioned before as well, very important is to get a good CWP upgrade in order to display the information in a way that it helps the ATCO and doesn't disturb it. So those are the three main components that need to be upgraded to implement.
And just for to help a little bit, if you decide at a certain point in time to implement FFI's release 1, we have developed guidance material for the flight data processing system requirements that cover the FFI's release 1. You are already, Morocco is already an associated member state to Eurocontrol. So the documentation, this documentation will be available to Morocco and to ONDA without any problem, and you will be able to use that to define the requirements for your new flight data processing system in terms of FFIs. On the second question, the relationship between free route airspace and trajectory-based operations. Free route airspace is a concept that we have started to implement in Europe since 2009. We are almost ready with the implementation. There are very small pockets or areas in the NM area where free route airspace has not yet been implemented. We know very well the good progress that Morocco is making with the implementation of the free route airspace. And in addition to that, there are very large areas where free route airspace has been implemented cross-border between neighbors. Now, it is not mandatory to have free route airspace in order to have trajectory-based operations, but free route airspace offers the choice to the airspace users in order to find a more optimum trajectory. So the goals of the trajectory-based operations will be fulfilled in a much better manner if you have implemented free route airspace rather than without having it. And I would just like to recall, ICAO has a very strict concept about trajectory-based operations, and the presentations that we have received yesterday from Crystal and from Hank were very clear in the delineation of what is the trajectory-based operation concept. And it was an excellent presentation indicating to us what needs to be covered from an ICAO global perspective in the trajectory-based operations concept, if we want to be harmonized across the globe. Please.
Good afternoon, Ulrich Kage from Frequentis. I have a question about the C in the FFIs. It's about collaboration regarding for the release number 1. What I just heard is that the trajectory in the MUAC is compared with the trajectory that MUAC has. So if you received through a downlink the trajectory, it's compared with what the ATM automation system has, and then you can see if it differs too much or not. I would have assumed that MUAC takes over the trajectory because it's the real one, right, that is received. And now my question, it's a little bit complex to bring it into simple words. For release 1 for the flight planning, when I plan a flight, I have to file an EFPL. And so I also have to add the trajectory. So then I send it to NM. NM receives it. What does NM do? I would assume NM also calculates its own trajectory. And what do you do if those differs already in the planning phase? Do you have a back channel? Fixum can hold, if I understand correctly, agreed versions and planned versions of trajectories. Is there already an operational concept being thought of, and maybe also already in place to really harmonize? Because like I understand it now, Lufthansa will keep their trajectory throughout the flight, and M will keep their own trajectory. All you do is maybe compare at a certain stage, but it's not, as I would expect, that you really use all the same trajectory in the end.
I can probably try to answer this, but it's been a long question, and it's true, it's not easy to tackle it in simple words. But okay, to your question, what does NM do with the received trajectory in an EFPL? We effectively use it. We try to align as much as possible with the trajectory received. We provide back, as I said, the evaluation feedback, and that feedback also contains a trajectory. So the airspace user is thus aware of what the ATM expects them to fly. So this is the feedback, this is the collaboration that happens during flight planning. More collaboration and more negotiation will be possible with the planning service than with the filing service. But I was not supposed here to describe all the services, because then I would have explained that normally you do the planning service, you do your negotiation system to system exchanges, and when the systems agreed on something, you come to a common view on what the flight is expected to do in operation. Then you just file the flight plan using the filing service, and that particular action would be equivalent to a simple rubber stamping of what's been obtained in the planning. Is this really answering the question? I don't know. Hope so. If not, I think we've met before, so we can see each other in the coffee during the coffee.
Yeah, it helps, and but I would indeed like to continue a little bit the discussion, maybe coffee break. And yeah, thank you.
Other questions? I will start from the back and then we come to the front.
Hi again, Kostas Christoforou from IFATSEA. I have a quick question for Peter. Is related to the full implementation of functional airspace block in Europe. And what is the relevance you see for a successful implementation of TBO?
Could you please rephrase the question? I'm not fully.
I will repeat again.
Please, thank you.
What relevance and what influence you see from the full implementation of the functional airspace block in Europe, which we strive for so many years now to implement, for the TBO to be a success story?
Now I understood the question, but I don't know the answer, to be honest.
Okay.
Sorry.
I think it's a very interesting question. The easy answer to that would be wider the areas, better would be, more contiguous the areas, better would be. And it would have been good if these volumes of airspace could have been used to that extent. Now, you cannot exclude it, actually, and I would not necessarily mention functional airspace blocks here, but I would mention contiguous volumes of airspace. I was just giving earlier an answer to our Moroccan colleague on the cross-border implementation of free route airspace. We have major areas that do not necessarily, of cross-border free route airspace already, that do not necessarily belong to the same functional airspace block as they are currently defined. They include states who are not even part of a functional airspace bloc, who are not EU member states. And we have contiguous area of cross-border free route airspace across. We have the Danube FAB, we have the FAB CE, the Baltic FAB, and the Danish-Swedish FAB. Across 4 FABs, we have a contiguous area of cross-border free route airspace. So I think the important is the expansion, the contiguous expansion of trajectory-based operations in order for the airlines. I think Annie said it clearly. It's not needed just in Maastricht. It needs to be expanded. It needs to be expanded, and it needs to be expanded as soon as possible to gain the network benefits about which we were discussing yesterday. And there was another question.
Thank you, Razvan.
Then we will close because I'm being told that we are over with 5 minutes, but the coffee break will be slightly short. Just one question.
So my name is Raphael Pascal from Airbus. Yesterday during this session, you were contributing to, Razvan, an important figure has been given regarding the estimation of the benefits expected, assuming that 70% of aircraft are equipped with the function. And the other discussions from yesterday gives sharing difficulties about the complexity of the overall system makes that it gives the feeling that we need to wait for a critical mass of airlines to be equipped with FFIs, with a data link capacity of the aircraft before to have benefits. It's just a feeling that it can give. However, from the presentations from Peter and Ennis, on the contrary, it seems to show that for each individual aircraft equipped, there is an immediate benefit, both for airline and for the air traffic control. Can you confirm, please?
Yeah, indeed. One flight being ADSC CPDLC V2 equipped can benefit better than without it. I think when we talk about a critical mass, it's we're not talking about optimization of flights anymore, but we're talking about optimization of the traffic. So you need a certain critical mass to use the ADSC data to start I wanted to say globally in the center, but to start center-wide to take decisions. And then you're more in flow management, local flow management, and then you can get capacity gains. So if it's only one flight, you can have a efficiency improvement. Once you start talking about how can I increase the capacity of my center, then you need a critical mass of equipped aircraft. I hope this answers the question.
No, in that case, I would like to know what is this critical mass. But anyway, thank you.
I'm from 69. 69%.
Just to be careful, because what Peter and Ennis have presented goes beyond the FFI's implementation, yeah? It's not just the FFI's Release 1 implementation. It goes beyond, and this is where there was their plea. Let's go for the CPDLC V2 actually, because this is what is going to start bringing benefits. FFI's Release 1 is just the first step of the TBO concept. And now, unfortunately, we have to close it. David, most probably there will be further questions, but just photograph our 3 colleagues there and myself, and we will try to answer during the coffee break. And I will let you announce how long the coffee break will be.
One more question.
I can have one more question. Okay. One more question.
Okay. No.
2 more questions.
In fact, it's a question related to the question from our colleagues from Morocco. In fact, the impact of free route airspace on TBO, there is an impact because a large area in free route airspace means less waypoints. So means it has an impact on EPP. So your question for me is very relevant. And to be honest, today, for me, it's something that is counterproductive regarding EPP because there is less waypoints. So for the ATCOs and to control the flow, or even each aircraft, there is less information regarding the progress of the flight. You see what I mean? If you have only entry point and exit point as a waypoint of the trajectory, it's maybe not enough to really make a fine-tuning of the flow control or even the individual aircraft control, no?
we can have a long debate on that. I think we need to be more innovative in how to exploit the benefits of the new concept. If you stay on the fixed ATS route network, you just accumulate the constraints instead of spreading them. But okay, that's a debate. Yeah, and Augustine?
Very shortly, I think we should certainly make a distinction between what a route is and what the trajectory is. Okay, the FFI's route trajectory information contains both the route, but also trajectory details. So what you're talking about, I think it's more a route in a free route airspace and not necessarily trajectory. So you might have in between the two route points, additional trajectory points.
What we see in many areas in Europe where free route airspace has been implemented, we see increases in capacity actually, where in the areas where we see still fixed ATS route network, unfortunately, despite the fact that there might be new systems, we don't see an increase in capacity.
No, Razvan, I agree with you. I agree that free route is giving benefits. It is not the debate. It's simply that in terms of, let's say, the EPP, the usage of EPP is a bit less convenient because there is less waypoints. That's it. Could be.
Okay, I like those. I like those debates. One single question, I think it was there in the back. One single question.
Sorry, that's me between you and the coffee. Eugenio Diotarevi from MyFATCA. A question for Enis. Well, for sure, TBO needs a lot of automation, and automation, especially for controllers, means trust on the system. So personal experience and daily experience is that sometimes when you ask to do something to a pilot, they say yes, but they don't do that. So especially for a top of climb or top of descent, how reliable are these points? And can you ensure that, for example, if I want to use the top of descent for separation, you are able to descend at that point, or for any reason you have to wait a bit longer? Thanks.
Thank you for the question. Well, this definitely needs a change management in how to use the FMS and how to achieve the benefits from ground. Today, we don't care, maybe do not really care about the optimum top of descent, which is calculated by the FMS, because we are changing the stars from time to time according to the experience we have. But when we are going to use EPP data, we have to do the change management in the cockpit and on ground as well. So the pilots needs to know that the top of climb they're seeing in the FMS is going to be shown downstairs as well. And it should be feasible. So this needs to, or leads to a change management in how we have to work in the cockpit and on ground. And if we manage this change management, we will able to get all the benefits.
Many thanks, Enis. And we will conclude here. TBO is really one of the best concepts that have happened over the past several decades, I would say. When we talk about real implementation, of course, the questions are there, but it works. So just to reassure in this global symposium that it works very well. Thank you, and I apologize for the 8 minutes delay.
Thank you very much, Razvan. Great job. And I hate to be the bad guy stopping questions, because that's what this symposium is for. But I guess also this is, we're experiencing trajectory revision during execution, right? So we're going to break for coffee. We're changing the start time by 5 minutes. So we'll resume at 15:50. Don't forget the exhibits outside. And please, when you do come back, please be on time. You don't want to be late for the next session. Thank you. Okay, we'll resume in 1 minute. So welcome back for the last session of day 2 of the symposium. And welcome back to the online participants. We're just waiting for a few more people to come back into the room here in the Europa meeting room. Because we need people in the meeting room. Welcome back into the room. Please take your seats quickly because the action is about to start. Okay, so this afternoon we have one more session left, which is looking at regional perspectives. And for that, I'm very pleased to introduce Colleen Harisco, who is the Director of the Air Traffic Organization for International at the Federal Aviation Administration in the United States, and also my counterpart in the cooperation between Cesar JU and the FAA under the EU-US MOC, which was mentioned earlier today. So with that, Colleen, the floor is yours.
Good afternoon, everyone, and thank you, David. Thank you, Eurocontrol. Thank you, Cesar, for putting together this incredible event. So really appreciative to be able to be here. So our session is called Regional Perspectives, and we're going to look at that from an operational point of view, through an operational lens. And we haven't really done so much of that in the last however many, 36 hours or so. And I'm also keenly aware that I stand between you and your favorite Belgium beverage. So in the United States, if you follow US baseball, there's typically 9 innings, right? And in the middle of the 7th inning, we have what we call the 7th inning stretch, where people stand up and stretch and sing a little song. Well, we're not going to do that, but we are going to play a little bit of a game. So we have talked about, TBO, all the enablers that we need. you know, the regulatory framework, what that looks like, what the global implementation is going to be, is the impact on safety, efficiency. So when we look at today's airspace, right, and we have an aircraft somewhere. And our goal every single day of every single one of us in this room is to make sure that the number of takeoffs match the number of safe landings, right? When at the end of the day, that is our goal. If we can do it efficiently, if we can do it flexibly, if we can do it sustainability, you know, with some sustainability in there, that is just icing on the cake. But our goal, our purpose is to make sure that everybody takes off and everybody lands safely. So we're going to do a little demonstration and we're going to send that ball, not around the room. We're going to send it across the room. So wait, there's more. So show of hands. Who is a former or current air traffic controller? Okay, you guys should be good at this game. Pilots. You should also be good at this game. ATSEPs, right? Engineers, people that are like making sure that the air traffic systems run efficiently. Good. Mathematicians. You guys will be kind of helpful. Okay, so what we're going to do is we're going to start with that ball right there. And we are going, now you're probably going to have to get up and there's going to have to be somebody in the center of the room because we're going to call this Canada. All right, so it's got to get through Canada over there. So you're going across the room with that ball. Go. Toss it up in the air. Okay, can't hit the ground, right? There's got to be somebody there. Who's going to be there? Oh, thank you, David. Come on, keep playing. Oh, we had a little bit of a weather deviation because we were going that way. There you go. Okay, oh, keep it going, keep it going, keep it going, all the way across. No, oh, goodness gracious. We're going, oh. So, okay, well, let's stop for a second because we did really, really, really poorly in that example. So, it can't hit the ground. Hang on a second, hang on a second. It can't hit the ground, right? Because then we failed in our duty. It can't hit the ground. It needs to go across the room. Okay, it's taking off over here. It's going to land over there by Ari. We're going to say Ari because he's the tallest person I see over there. So it's going to land by Ari, right? So we're going to take off. We're going to go across there. You might have to stand up. And keep in mind, this is not like, you know, beach volleyball at the Olympics. It's not a competitive sport, right? Just trying to get it from there to there as easily, as efficiently, as safely as we can get it there. So we're going to try again. There we go. Okay. Nope, starting there. Okay. Give it to, there you go. Give it to Steve. Steve's going to start us off. Again, we're going to need some people in the middle. Some people need to go to Canada. Who are they? Come on, come on. Thank you, Andres. Thank you, sir. Thank you, David. All right. We're going from there to there. Oh, goodness. You're going the wrong way. It's not supposed to hit the ground. It's supposed to go in a straight line. Back towards Ari. He's standing up. How can you miss him? Oh, yay. Okay. To be perfectly honest, I expect that to go much easier is really what I had in my head. It was going to be really easy to get that ball from there to there. So now what happens? I think we've already seen it when we add more demand to our capacity. So we have some more beach balls that will be flying into the airspace. Again, our goal is to get them to the other side of the room. There may need to be more people in the middle that maybe don't work for Eurocontrol. Thank you okay, where's our next ball coming from? Here we go, Steve, go. Everybody, you need to be looking. Oh, crashing and burning. Here we go, more balls. They're supposed to go to the edge, to the edge. Again, not a competitive sport. We're moving them across the room. Moving them across the room. Moving them across the room. They can't hit each other and they can't hit the ground. We're not very good at this.
Reminded me, this is free rooting at its worst. Free rooting at its worst.
Okay, so the point of our little exercise, as we come to a close, second, that's fine. If wherever they end up is fine at this point. So the purpose of this little exercise was to see how many people in our current air traffic control system touch an aircraft as it flies across the, again, we didn't do a very good job in our duty today. We have one that really crashed and burned. So how many people and technologies, right? And I think Steve Bradford had an example yesterday when he spoke about, the aircraft talks to the controller, and the aircraft talks to the FMS, and the FMS talks to the AOC, and the AOC talks. And so all of these different points, right, that go back and they connect to the aircraft. And that's what happens today. So what does it look like in TBO? And then what does it look like from a regional perspective? And so I'd like to introduce my very esteemed colleagues, which you all probably already know. Ivan, I knew I was going to do it. I was been practicing all day. Pendachansky, he's the head of the Network Management Strategy Unit, and Jose Simon is an ATM expert for Eurocontrol. And Jose, I just found out that Eduardo Garcia is a friend of yours. He texted me just a few minutes ago. Sean Ho, Deputy Director for CAS, the Civil Aviation Authority of Singapore, and Blake Cushney, my friend from NAV Canada, is the Program Director for Service Delivery. And so we're going to start with Network Manager and Ivan and Jose Simon to give their presentation on what the regional perspective for TBO looks like in Europe. So thank you.
Many thanks, Colin. So we will do this presentation as a duo with my younger colleague. So I will start. Oh no. Where is the first slide?
No, sorry.
Okay. So I would like to say a few words. What is the Eurocontrol NM area? So it is the area that is part of ICAO EU region, for which we do different type of services. One is IFPS zone for the flight planning, and we also do ATFCM services in IFPZ and adjacent areas. The adjacent areas are Iceland, Algeria, Tunisia, Egypt. So what here, in order to accommodate the traffic in between IFPZ, we are facing with the increased number of the flights. So compare it with 37 flights in NM area in 2019, we aimed to go to the 50,000 in peak days in 2029. So we need to accommodate unexpected strong traffic growth. We also need to accommodate scalability, volatility of the traffic. So in order to manage this traffic at the level of IFPZ and most importantly by Network Manager. We developed a network for the CONOPS that address the substantial improvements of the European ATM network in terms of capacity, flight efficiency, predictability, and sustainability. So it does contain conceptual elements, what needs to be done by all network actors, by all stakeholders by 2029, hoping to have a consistent trajectory management within IFPZ by that time. So why we are doing this? So we are not doing just for fun. So we inherited many things, many legacy components that Jose will explain in the next slides. So we have CFMU, IFPS that was put in operation in the mid of the 1990s. And we are aiming to improve this, to enhance what we are currently doing. So this CONOPS is identifying the conceptual elements to fulfill the network strategy plan. So network strategy plan is the document that is approved by the European Commission, where we put in sequence the strategic objective and actions for all actors, including NM, INSP, airspace users, airports. So this one is called implementation and coordination of end-to-end for 4DT business and patient trajectory at the network level. The title might be a bit confused. Business trajectory and patient trajectory does not exist anymore. We went to the different, but at the time when NSP was prepared, that was the wording use. So it is initial prerequisite for INM. It will provide the contractors. I'm glad that I've seen Andres and Victor somewhere in this room at the conceptual level of what is expected concerning the management of the trajectory. So this will be used as a baseline for drafting operational and user requirements for INM. INM is our new system. I hope that many of you went to visit the new ops room. So it will be there. It is also needed as indication for the stakeholders and users, airports, what they need to do from their side to drive their planning and investment and achieve a common goal. So we hope that this document could be used to derive the common trajectory management requirements for all stakeholders. So I will hand it over to Jose to explain to us what are the principles and what is the improvements compared with the legacy situation.
Thank you, Van, and good afternoon, everybody. So I will mention a bit the guiding principles of this 4DT CONOPS. So of course, it adheres to the Network Strategy Plan 2025 to 2029, especially focused on fulfilling the NSP strategic objective 4.3, implementation and coordination of end-to-end 4D business or mission trajectories. And it's of course fully aligned with the content of the overall network CONOPS at the Network Manager and also other NM documents like the Flight Plan and Flight Data Evolution Strategy. It includes actually all the capabilities which are mandated by the CP1 in the SSR deployment program, and also ICAO SBUs and SARPs, also integrating SSR solutions and OS steps and enablers, those that are mature enough and expected to reach V3 by 2027, 2028, and then could be deployed by 2029 are included. Others with lower maturity expected to be mature beyond that timeframe are only covered as aspirational goals. As Ivan mentioned before, I will now briefly try to give a non-exhaustive but hopefully clear enough idea of how we are building the trajectory and how we are having trajectories, and especially the exchanges that we have at European level for this purpose. So what you can see on the screen is the current processes, current exchanges that we have in pre-departure, so during flight planning mostly. As you can see on the bottom right of the screen, you will see that the text in blue indicating exchanges which are taking place with the ETFMS, the Enhanced Tactical Flow Management System. That is our main ATFCM system for the purpose, at least of the time frame in this presentation. And in green, the exchanges which are with the integrated initial flight plan processing system, the main flight planning system. So right now on the slide, as I said, you have the flight planning, mostly the flight planning processes. So all the text, as you can see, is in green. And it means that obviously at the level that we are now, we are receiving in IFPS, in the Network Manager, all ICAO 2012 flight plans. You can see on the screen, flight plan change, delay, cancel messages from the airspace users, and also departure and arrival messages. So those flight plan messages are then processed by IFPS, and then this triggers an acknowledgement or rejection of the message, which then allows a certain level of negotiation with the airspace users. Those also flight plan messages that have been acknowledged will then be subject to a regular revalidation process that can trigger then also to be further negotiated if arising restrictions forbid the route that was initially planned. So this then, after the successful processing of the flight planning messages, IFPS will distribute these flight plan messages to ETFMS internally here in the Network Manager, and also to the different ATS units that are crossed by the flight. On top of that, of course, we have the option for the request of flight plan or request of supplementary flight plan data, RQP, RQS message that you have there on the screen. So at this stage, we have in the two main systems at the NEM, two trajectories, one trajectory in each side, which is pretty much the same, and that will coexist at this point, one in ETFMS, one in IFPS. As we proceed to the departure of the flight, we get to the preparation of the departure, and here we will have a few more inputs. And as you can see, we have some text in blue, which means that we have some exchanges that will take place for our enhanced tactical flow management system. Of course, during this time frame, we can still have flight plan updates that you can see on the left. So airspace users can continue to actually follow provide flight plans or do any amendments to those flight plans. And then you will also have an important input, which is the departure planning information from airports. There are many actually airports in Europe, the major airports in particular, that provide updated estimates of the off-load time for the aircraft. So this information that you can see, DPIs, are actually provided to ETFMS, which then is used to update its trajectory. So the flight plan data that you can see is used to update IFPS, and then in turn, this is also distributed to the ATS units and ETFMS, so it will update ETFMS trajectories. And DPI information will update actually ETFMS trajectory only. So what happens also at this level is that we will enter into the role of flow management. And in this case, ETFMS will be able to start with the demand capacity balancing and be able to, in this case, distribute different target times. So these are the slots, the different, the ATFM ground delay that is distributed to airspace users and NSPs to respect capacity. And at the same time, ETFMS will start to distribute what we call ETFMS flight data, EFD. This is quite comprehensive information of the flight available at the Network Manager, which is distributed to those subscribed users, typically for local flow management tools. Then we continue to the execution of the flight. And here I will start with the processes that take place outside of the NM. So here on the screen, you can see that between the different ANSPs, between the different ATS units, coordination and transfer is performed with the online data interchange as flights are closing to our boundary. And then between, of course, the ATS units and the aircraft, you have data link also deployed in some areas. Regarding the NM, NM is also receiving ADSB reports, so current positions through ADSB. And through various surveillance means, of course, ANSPs are receiving position reports, which are also distributed to the NM in the form of CPR's correlated position reports. This data is used to, of course, update the trajectory at the NM, in particular in the ATFMS. And then there's also the possibility to have airborne flight planning. You can see AFP there on the screen. These are ATC flight plan proposals that are filed to IFPS and then distributed to ETFMS and all other ATS units as ATC flight plans, ATC change messages. I will hand over to Ivan.
So we are going to the required improvements. It takes a bit longer, so it address all the phases, pre-departure, departure, and flight execution. So the common goal is to establish a common agreed trajectory that can be shared, used by all stakeholders. Our goal is to provide a trajectory that can be used by different stakeholders and different services, ATFCM, planner, extended planner, multi-sector planner. And I would like to stress that we don't intend that the NM trajectory could be used for the tactical ATC. On the next slide, you will see the improvements in the pre-departure phase. They are already elaborated by Augustine, so I don't want to keep you busy. We have PDPIs that are coming, and the NM trajectory service with the distribution of the ground agreed trajectory. So this is something new. So in the departure preparation phase, we still have DPIs, PDPIs, and APIs. We'll continue the pre-departure updates and revision. We have FFI's distribution service and NM trajectory service distribution of ground agreed trajectory. So here it's a drawing that shows how this trajectory that we provide can be locally used by ATC unit for different purposes, ATFCM extended planner, when they will be synchronized and desynchronized. So it is clearly indicated with red crossings, and how we will receive the updates of this trajectory by different means of FSA, CPRs, new services, all the modernization that will provide us coordination and transfer updates. So the last slide is very complex. So it is something that will happen in the execution phase. So we try to put some processes that are not existing, like the current CDM process. We also have EPP reception, so ADS-C reports to update the trajectory. We have tactical updates from INSPs. We have the result of the coordination and transfer that could be shared as called modernization. We still will permit legacy exchanges, and the coordination and transfer between INSPs could be done according to their own needs and requirements. So I think that we exceeded a bit timing. Many thanks, Paulina.
Thank you.
Thank you, Yvonne, and to Jose. Sean Ho is our next presenter from the Civil Aviation Authority of Singapore. Sean, thank you.
Right, thank you. And good afternoon. First of all, I would like to thank the organizers of this symposium for having a session on regional perspectives. It is very thoughtful. While ICAO and ATM-RPP harmonizes the development and deployment of the global TBO concept, the way each region works on its realization is expected to be very different, right? Because the needs may be different, the challenges we face in each region are different, and last but not least, the way we organize ourselves is different. And on top of it, as Hank pointed out yesterday, TBO by itself is an effort on transformation. And I think that from the perspective of Asia Pacific, it is a collaborative effort on ATM transformation between stakeholders on the regional scale. So I hope that this sort of answers the questions on why TBO realization is not going to be easy. You also mentioned in the first day, yesterday of this symposium, but I believe that it can be accelerated. Hence, this brings me to the next slide. And to talk from a regional perspective, I feel that there's a need to define the region. And in this presentation, the region that I'm talking about refers to the Asia and Pacific region as defined by ICAO. And there are 39 contracting states, and efficient improvements impacting the region is undertaken through the Planning and Implementation Regional Group, or APAMPER in short, and also through its technical contributory bodies in areas such as CNS, ATM, and aerodrome operations. And the improvement guidance document is what we call the Asia Pacific Seamless ANS Plan, which is referenced and anchored to the Global Air Navigation Plan, or GAMP in short. As you can see on the slide, the current version of the plan, the implementation timeline is 2025. And the next version, expected to be adopted end of this year, will bring the implementation timeline to 2028. But why am I mentioning this, right? All of us in the room realize that if you're talking about TBO, the timeline is too short. And the title of my presentation is titled the APEC TBO Pathfinder Project. And one objective is to fill this gap to help Asia Pacific define the long-term plans towards TBO realization. And well, Amo from Aerothai covered this yesterday in session 3 on research and innovation. To recap, in the year 2020, a number of ANSPs in Asia Pacific and North America came together to work on what we call the multi-regional TBO demonstration project. And the purpose is to identify, mature, and demonstrate key TBO capabilities related to the sharing, maintaining, and related to the sharing, maintaining, and using of the trajectory information. And over the next 3 years, the partners came together to collaboratively curate operational scenarios to simulate and better understand capabilities such as trajectory negotiation amongst ATM stakeholders, enhanced demand capacity balancing, and improved CDM. This collaboration is important to us because it allowed an opportunity to envisage how TBO might be for Asia Pacific. And as a result of that multi-regional TBO demonstration project, it seeded the next collaborative efforts in what we call the APEC TBO Pathfinder project. And in session 1 yesterday, DG Yoshida from JANS mentioned this particular project. And as the name suggests, the Pathfinder project is to discover pathways, and if I may use the word roadmaps, to the realization of TBO to its defined end state in Asia Pacific. The project is expected to define high-level plans and to chart the path towards the evolutionary step 3 of GAMP. And a bit more on the project is that it was formally launched on 23rd October last year, and it now involves 9 ANSPs, KENSO and IATA in Asia Pacific. And over the next 4 years, we will collaboratively work on 3 key activities. 1, it is to answer the question that in future, when Asia and Pacific talk about TBO in our region, what do we mean? And what will be the key intermediate phases for us? And what will be the roadmap? Next, we'll also identify and develop priority TBO scenarios for the APAC region for the demonstration phase. And last but not least, for the demonstration phase, we're bringing ATM stakeholders together to demonstrate TBO processes. Someone asked me the question the other day, where are the airspace users or airlines represented? So in the project, IATA represents the airlines, and in addition, the ANSP's project participants will bring in the respective airlines from the states if required. And well, I have to be quite honest here, we are still quite early in our project, and we just had our kickoff meeting 2 months ago. And at this kickoff meeting, we agreed on a couple of things. First, we set the goals of the project, and the details are in the next slide. We agreed on the way to organize ourselves. There will be 3 work groups. We define the key deliverables. We define the related timelines of delivering those. And it created an opportunity for all, okay, I'll say for many, in Asia Pacific to come together, share their individual plans from a national or from an ANSP perspective, so that collaboratively we start to form a picture of what might be practically achievable. And one last point, an outcome from that meeting is that we will take into consideration the different needs of participants in Asia Pacific. As such, we have catered for a tiered participation to encourage and broaden involvement and to bring as many ANSPs into the conversation and incorporate their needs early. Okay, now a bit more details. Then this slide shows how we are going to organize ourselves. And if you look at it now, and if I look at it now, it sort of reminds me of the agenda of this Global TBO Symposium. Right, to left, that little column in green, it talks about, what is TBO for Asia Pacific. We want to raise the level of understanding of what the global TBO concept is, both at the executive level and as well as the technical community. And this is important for us because we want to make sure that TBO is and remains a priority for key decision makers. And at the same time, the technical community in Asia Pacific understands well what is required and to size up the resources accordingly within their own organization. So that's the left column. The center column in blue is about operational priorities within Asia Pacific, as well as putting in place the more matured enablers. So for example, we need to identify which city pairs will benefit most from TBO implementation as a start, understand how operations will change, understand how processes will change, and last but not least, how the role of the human actors will change. To the right in orange, it's about why TBO, that sort of was briefly touched on in session 1 of this symposium. What are the operational benefits for Asia Pacific? And it also partly addresses the how. How do we want to achieve it in our region? What are the roadmaps and what are the steps? And we expect that there will be substantial heavy lifting from the leads and members of each work group. Okay, at the moment, this is how it looks. It's a busy slide after the initial planning phase. Substantial works needs to be done just for the definition phase for Asia Pacific to come up with the initial roadmap. And again, I hope it answers at least partially why TBO and the realization of it is not easy, at least from the perspective of Asia Pacific. And after all, TBO is about changing how I would say transforming how the ATM community interacts through evolutionary steps, if I may quote from the Global Innovation Plan. Okay, in summary, I feel compelled to reach out these 3 points because I feel that it is quite important, at least from the Asia Pacific perspective. The project itself creates the opportunity for APAC ANSPs and CANSO and IATA to collaboratively evolve the region towards TBO. Next, it facilitates a common understanding of what TBO means and what it is for Asia Pacific. And if I may add, what the region wants from TBO, but yet aligned to the global TBO concept. And going forward, because of the expertise this platform is bringing together, I think the Pathfinder itself can be a focal point for Asia Pacific to collaborate on interregional TBO developments and harmonization. I think, thank you. That's my last slide.
Thank you, Sean. And last but by no means least is our colleague from NAV Canada, Blake Cushney.
Thanks, Colleen. And first of all, thanks everyone for the opportunity to come and share a Canadian perspective on TBO. So I'm an ATC ops background, so I'm going to take a little bit of a different perspective in this presentation. We've heard a lot of wonderful stuff about, the flight plan and the technology that's going to enable it. I'm going to talk also about what we need to change in the operation, because the reality is if we don't make other changes as well, we're not going to realize the benefits that we've talked about for the last couple of days. So we're just going to talk about some of the things we've done, some of the things that we've done by default that actually look like they're good for TBO, but we didn't mean to at the time, and also what we need to do in the future. So we'll talk a little bit, as I say, about the operational building blocks. I'm going to actually start with a video. I thought, being the coveted last session of the day, it might be a good time to play a video. But it's also a thing we've put together to sort of help our own internals understand where we're going. It's not overly technical, it's fairly high level, but it kind of explains the different moving parts we see that might need to change in the ops room. I hope it works though. Let's see.
NAV Canada is part of a growing industry that connects us, drives the global economy forward, and serves a world in motion. Our employees handle more than 3 million flights annually, and in doing so, rank us amongst the safest and most efficient air navigation service providers in the world. Still, we are challenged to do more, to prepare for increased regional and global connectivity, and to reduce our industry's environmental footprint. That's why we are making significant investments to improve traffic management across all of Canada and beyond. NAV Canada is leading an industry-wide effort that will transform the tactical operation of today into a full strategic TBO environment for tomorrow. By leveraging network management and integrated operational decision support tools, controllers, pilots, dispatch, and airport operators will have a common view of the operational picture. Flight planning will be enhanced to allow for optimal trajectory, providing air traffic controllers with routings that increase system resiliency and take into account capacity at the destination airport. Enhanced sectorization and procedures, accurate weather data, and new surveillance sources will make en route phases of flight more efficient, allowing aircraft operators to look beyond their conventional flight plan to benefit from changing jet streams, weather conditions, and traffic demand. These are the building blocks of a full, free routing environment that will result in shorter tracks, reduced fuel burn, and reduced greenhouse gas emissions. The program will extend the planning and sequencing horizon for our busiest airports well beyond terminal airspace, enabling traffic management decisions upstream that will make terminal sequencing simpler and more efficient. If airspace infrastructure becomes unavailable due to convective weather or other constraints, adaptive air traffic management planning tools will provide solutions that maintain throughput. Complementing innovative arrival management technologies are new separation standards and tools that ensure the use of valuable space on final approach is maximized. Enhanced weight turbulence spacing and time-based separation will increase the arrival rate, reduce delays, and the use of flowing patterns. Together, these systems will drive the industry towards a predictable and adaptive gate-to-gate operation that starts before an aircraft pushes off and provides for a complete 4D trajectory planning environment for Canada's National Air Traffic Management System. This will enhance airspace resiliency, increase situational awareness, and improve how aircraft are spaced and sequenced, while maximizing benefits for our customers, our partners, and the communities we collectively serve.
So lots of stuff wrapped up in there. And as I say, it was kind of it's to help us all understand where we're trying to go, because it's a complex topic, right? There's a lot to unwrap. So I'll start trying to go through some of these. I'll not go into all of them, but airspace modernization. We think this is key to the success of TBO. We really have to have a structure that's going to enable the improvements that the system can bring us. So we have worked over the years for a full PBN environment. We're pretty much there. We're trying to build structure only where it's required, free route. I mean, you probably saw Jason's map this morning. A lot of Canada's empty for airspace, right? The free route up north is okay, but if you look along the border, it's pretty busy. So we still have the same challenges as everyone else, but we really want to get free route where we can all the time. Flexible use airspace has been talked about, but the other piece we need to change is really our sectorization. We've modernized our airspace, our routes are PBN, but most of our sectors are still built the way the VOR network used to be. The vertical splits are built for props that used to cruise at 200, and now you get, the Q400s that cruise at the old jet altitudes. We have to modernize the structure. We also need to make them bigger and more dynamic. We don't want to restrict the perfect flight plan for customers because the sector that the jet stream is better for today can't have greater capacity. We need to make sure that capacity is movable to some extent. How we're going to do that will likely be bigger specialties with more splits that can move more dynamically across the sector. And also, obviously, we've talked a little bit about new entrants. We have to make sure that we're built according for that. So really, if we talk about the flight plan, all the great things we can do, we've talked a lot for the last couple of days about the sort of middle sector of this, but we need to do all these parts. Otherwise, the middle sector benefits. And I think somebody said it earlier, it's great getting all of this, but if you get a 20-minute hold at a bedpost, you've lost all the benefits we've spent all this time trying to create. So we have to look at it as a whole system. There's lots of bits and pieces in here that are going to enable this that we believe. But again, we got to look beyond the en route for the entire trajectory of the flight. So part of doing that, and this is the piece I talked about by default, where we feel this is good for TBO. Quite a few years ago, we initiated a national RNPAR program, and some people are probably thinking, why am I talking about RNPAR here? Well, those who know me know I always talk about it partially, but also by default, we've discovered it's actually really quite good for TBO. It was built for environmental benefits, essentially reduce fuel, reduce noise, or certainly reduce population overflown. But it gives a very clear defined path to the runway, which is therefore a very clearly defined time to the runway, which really is going to help us with TBO. So if we think about today, sometimes final approach is 8 or 9 miles, sometimes it's 25 miles. That's a massive time deviation. So we think it's one of these things that'll help us. And I've got a quick bit of radar playback just because I'm a controller and I like to see it still. So this is our Calgary operation. You'll see a couple of curved approaches on either side and a couple of dashed straight lines. And I'm not going to go into too much detail about what it is today. Those who want to understand more, happy to talk offline. What I'm trying to show here is this is a 20-minute segment. There's about 20 arrivals, but only 4 of them get vectored to final. So that's what we start to think is if we can get our time-based management to enable more aircraft to fly this kind of approach, therefore we can actually take a step towards the gate-to-gate trajectory where our time management is a little bit more improved. So I'll let that run just for a second or two. We'll not spend too much time on it, but essentially everyone is now flying a fixed path, fixed time approach to the runway. So therefore, when we know the time at the top of descent, the time at the beginning of a star, we pretty much know their touchdown time long before they even leave the cruise altitude, which is something that, again, none of these are TBO on their own, but they're all these operational building blocks we think will help us get there. This is data from our colleagues in Denver who do a lot of the established RNP operation where you're using like that standard that we created in ICAO a few years ago. And I'll just point out quickly, you can see the standard deviation for RNPs is essentially 0, but a vector to final in the bottom line there, the standard deviations over 10 miles. So it's a lot of variation. And how can we really get good accuracy, you know, A-man, D-man, everything, if we're still vectoring somewhere that, you know, maybe it's 8, maybe it's 30, we don't know until the day. Anyway, ATFM initiatives, it's been mentioned a few times, very, very clearly a massive part of what we're trying to do. We have arrival managers deployed at our 4 majors. We're connected with the FAA through the gateway. We use the traffic flow management system, and we do some common flow sharing, but we need to do more than just this. AMAN is fantastic, but again, not TBO on its own. So what else do we need to do? We're looking at departure managers, integrating departure manager with an arrival manager. Ultimately, every departure becomes an arrival. If you want your arrival to be on time, they got to leave on time. And to do that, we have to manage the traffic to ensure they can leave when they need to. Extended metering has been talked about quite a bit, and it's very important. Enhanced cross-border ATFM clearly is key for all of our successes. TTO or RTA initiatives. And we actually have one that we've been running for a few years now. We have a curfew in Toronto until 6:30 in the morning. But what happens is a lot of the West Coast red eyes leave the night before, they arrive too early. We end up stacking for a long period of time, which is very inefficient and also not ideal for noise. So we started an initiative a few years ago where we know generally what runway they're going to be on the next morning. We send a bedpost time through ACDM that goes to the AOC, that goes through the ACARS to the aircrew before they leave their departure airport at San Francisco or Vancouver, wherever. And they miraculously arrive at the bedpost on time. No, we don't stack anymore. And so it works. Now, having said that, that's just overnight. So we need to expand how we do this. Obviously, EPP looks like the long-term solution for that, but we want to still do it in the interim with RTA or some other initiative. So these are things we're working on as well. So weather. It does have a massive impact on our operation. If we think about this kind of concept, you know, if we can get all these things working, doing this on a day that's got no wind, no issues, we might be able to pull it off. We might be able to do TBO. We might have our aircraft at their planned arrival times. They might hit their meter fixes. They might have their en route spacing correct. But what happens when it doesn't work? Which actually in 2019 in North America, 68% of delays were attributed to weather. So TBO only being good for 30% of the time is not going to deliver the benefits our customers and our environmental parts of our government require. So what happens on a day like this? Well, let's say there's some crosswinds at our runway, or there's a high headwind and therefore landing rates are down. Or in our case in Toronto, if we get a strong crosswind, we have to switch to a different set of runways, we lose capacity. These things will still happen, but what the problem is today is it's totally unpredictable. It'll drive unexpected holding. It means you can't manage your bedpost arrival times. Throw in some convective weather, which is fairly common, certainly on the eastern seaboard of the US and Canada. And what happens is unexpected ground stops, diversions, extreme holding, and essentially chaos for the traveling public. Now, we can't change the weather, but we are working with our partners at MIT Lincoln Labs in Boston on predicting it better, and within that, predicting the impact to capacity and the impact to demand at the same time. So while we might still end up going to that cross runway scenario and we're going to drop our landing rate, if we know about it earlier at a certainly higher level of certainty, we can have those discussions with our customers. We can pre-plan our ground delays. We can, you know, put the CTOTs out earlier. Aircraft customers can upgauge if they need to on certain routes, if that helps the traveling public. But it's all about prediction. So we've got a set of tools we're developing with MIT. One of them is just a general sort of Canadian weather system with synthetic weather that covers areas where we don't have radar these days. We've got a tool called ACEPT, which is basically looking at the airport. What is the arrival rate? What is the demand and what is the weather impact in that to try to help us predict better what we're going to have to do several hours in advance. And then we're looking at convective weather impacts on certain bedposts or impacts on the terminal in general. What's that going to do for the demand? And all of this comes to these 4 sets of tools that are going to give us, we hope, a better prediction of the weather, and more importantly, what that impact is for us. There'll be times that we'll go to a cross runway, but it's not an issue because demand at that particular period, maybe we get lucky, maybe it's okay. But there's other times that we really need to look at in advance. So these 4 tools are things that we do think, again, are foundational to make TBO real all the time, not just on the occasional day where there's no bad weather. And being an Irishman, I can assure you that doesn't happen. So, so how are we going to pull all this together? There's a lot of stuff going on here. We can't just throw these tools out there and expect our controllers and our supervisors and everyone else to manage it. So obviously, over the last couple of days, everyone's been touring the fabulous new network manager next door. I can promise you ours will not be that nice, much and all as we would love it to be. And it'll be slightly different as well. Obviously, network manager here is really managing all of Europe, you know, the 41 states or whatever the number is, very, very complex, managing the en route airspace. Whereas if we look to the FAA command center, they're doing a lot of airport management as well. We see our network managers a wee bit of a blend of both. We really need to manage our airports to enable this en route, but we also need to manage like network manager does here. So as I say, ours will not be as beautiful, but hopefully will be equally as beneficial to our customers in the long run. And that's how we're going to pull all this together. We're still developing this. We don't know exactly how it's going to look in the end. But it'll have the flight planning functions, it'll have flow management, it'll be managing capacity demand, obviously the weather we've talked about, airspace constraints. We're a big believer in having a sort of sandbox what-if concept that we can pre-discuss with our customers what the right solution is. A lot of the times we have challenges today to make sure we pick the right ground delay program or the right thing for the customers, and it's not always easy. And we need, you know, to use this to coordinate closely with our southern neighbors in the FAA because of our interaction. And yeah, 0 seconds. Thank you.
Thank you so much to Yvonne and Jose and Sean and Blake. So I have just a couple of questions that I'm going to key up for them and hopefully it will address some of the questions in the room. And I, again, very cognizant of time and the end of the day. So on cross-border operations, so we talked about this a little bit. TBO requires coordination across different airspaces, especially in densely trafficked regions. How have you collaborated with neighboring countries or regions to manage cross-border aspects of TBO, or how will you? What challenges will you face and how will you address them? Yvonne.
Many thanks, Colin. So basically, Eurocontrol Network Manager is managing the cross-border operation between 42 member states. We also manage the cross-border operation currently with many adjacent ATS regions, so Egypt, Algeria, Tunisia. So we have plenty of exchanges that are currently taking place. We also intend to improve this to see when this adjacent region will be FFIs capable. So how to improve this? We currently use exchanges of slot allocation for the adjacent regions. So we provide CTOT. We got for the transatlantic flight updates. We also do with this region receiving airline updates even from Singapore that are integrated. So basically, many building blocks are in place. It will be, we intend to enhance in the future, as it will be essential to do this in a way that it's describe it with FFI Release 1, FFI Release 2, and how to improve the coordination between the regions. Thank you.
Thank you, Yvonne.
I suppose we go in the way as we are seated. In Asia Pacific, we have a ATFM steering group under APEMPERC, and that coordinates the ATFM activities in APEC. And in particular, we have implemented what we call a ATFM distributed multinodal concept of operations. Basically, through that mechanism, we are able to implement ground delay programs. But I have to caveat that not all states in Asia Pacific participates in the program. Yet at the same time, we have ongoing activities to try to broaden participation so that flow management becomes a bit more inclusive and is managed in a better way.
Thanks, Colleen. So unlike our European colleagues who have huge numbers of borders, we only have one, but it's very large. And 90% of Canadians live within 100 miles of the 49th of the US border. So all our traffic density is there from a regional level. We also have a lot of cross-border flights that are still domestic. So a Vancouver to Toronto, depending on the winds, will often go through the FAA airspace, and a Boston to Seattle will often come up over Canada. So we already have, reasonable, I would say very good collaboration. We've worked on a lot of stuff great over the years. We're part of the TFMS system. But I think for TBO, we still need to do better. We still need to have, the Toronto controllers who basically everything from this part of the world going to Chicago comes through Toronto Centre. We need them issuing the TBFM times that were mentioned by your FAA colleague yesterday to help the Chicago controllers, and conversely, we need, the Cleveland and the Boston controllers issuing our times for Toronto, Montreal, or the Seattle ones for Vancouver to help us actually stream the traffic properly. So I would say, yes, we are in a pretty good place, as far as cross-border, but definitely still some, to really get to where we need to go in this, we've still got some work to do.
Thank you. I think it's important to note that, global harmonization and, collaboration doesn't mean we're all have to do the same thing, right? Interoperability means at the end of the day that we can talk to each other and things connect, but it doesn't have to be the exact same solution for everyone. So thank you very much. One more question, then I'll open it up to the floor. From your organization's perspective, what are the critical building blocks, and Blake talked a little bit about this, needed to successfully implement TBO? How does this align with the operational practices and technological capabilities currently in place in your regions? Sean, you want to start that one? Sorry.
Okay, for a change, I'll start first. Well, maybe I'll answer it from the region's perspective. We are a bit more focused on what is more matured in terms of enablers for TBO, i.e. SWIM and FFIs, release 1. For SWIM, there is a commitment for Asia Pacific to implement it fully by 2030. Yet at the same time, we know that we cannot sit back and wait for it to happen on 31st December of 2030. So some states and ANSPs have set up the SWIM Pioneer Implementation Group. Essentially, it will sort of build a prototype of the regional SWIM, and hopefully that forms a reference point or a blueprint on how the rest of the region will implement SWIM. That's one. For FFI release 1, we have set up a group that are looking at what are the processes and procedures that need to be further harmonized from the ICAO FFI's implementation guidance for release 1. And at the same time, we're looking at implementation timeline. So this is work in progress.
Thanks, Colleen. So yeah, I'll not talk about the operational stuff because obviously covered a lot of that there. I think ultimately, if I have to pick one, the data sharing is still absolutely the key, the SWIM feed. be it through the FFI, through the EPP. The data is all out there. You know, you can see it on your iPhone where your inbound aircraft is when you're waiting to turn, but you know, the gate still says it's on time, and our flight plan system still says it's on time, and you know the inbound hasn't left its other airport yet from your iPhone, right? But we don't have that in our air traffic systems yet. So to me, that data sharing absolutely is still key to everything. All the things I talked about there still require the data share and the SWIM to make it possible.
So from European perspective, the building blocks are those that we've mentioned, FFI, Release 1, that is we already deployed. We expect that it will be widely deployed by the remaining airspace users and INSPs. So we want to extend this in all phases of the flights, in the pre-departure, in the execution phase. So on the presentation that provided, we developed some equivalents that might come into the Release 2 that we would like to deploy a bit earlier, because for us there is a operational need of doing this to cope with this with the traffic demand. So we are not in comfortable position to wait to finalize all the discussions there. So basically the trajectory and trajectory service, the CDM process are something that could be included as a part of Release 2. We would like to implement a bit earlier with the baby and afterwards to see how to adapt this. Again, for us as a NM and the overreaching goal to manage that trajectory from ADEP to ADES in IFPZ, we need to have a real quality data of the actions, clearances, and coordination between ATSC units. So I would like to improve this, the methods how we will get this. So I hope that something of this was presented yesterday as a part of R&D activities. So and this will contribute for NM to manage that trajectory, to keep it, to have the agreed trajectory updated at any time and provided to the different upstream, downstream units, to the different stakeholders that would like to use it with the granularity that would enable not only the utilization for ATFCM purposes, but for other services like extended planner or multi-sector planner. Thank you.
Thank you. Okay, I'm going to open it up to the floor. I did have a demand and capacity question, but seeing all the balls in the middle of the room, we didn't do very well with that. So we're going to move on to questions from you guys. And again, I know it's getting late in the day and everybody's ready to get out of here. But surely there's a question in this room. Did we do so good that you have no questions? Wow. Wow. All right. I'll give you 3 minutes back, David. Thank you so much. Thank you, gentlemen. Appreciate it.
Thank you, Colleen. Maybe everyone's exhausted after running around after those speech balls, although maybe that's just me. So I think we've had a really full day. I said at the beginning of the day we had a packed agenda, and we did. I'm impressed that so many of you are still here. I think I've only seen 2 or 3 people leaving early. So thanks for sticking with us. Also for the online participants, I hope you found it valuable. It's been a really in-depth discussion on a lot of different topics about TBO. Tomorrow, we're going to have a session on the military aspects related to TBO. And then we're going to have a session looking forward and, dare I say, talking about TBO roadmaps and next steps, including the regulatory and standardization aspects. So that, I hope, will wrap up the topic, bring everything together, and hopefully start to sketch out a way forward. This is clearly a topic with a huge number of different dimensions, and I think we all agree that it's time to get moving at global level on moving forward. So that's the agenda for tomorrow. We'll be starting at 9 o'clock tomorrow. So there is still one more tour, I think, although I don't see it on my screen, starting at 5:30, the Purple Tour. So if any of you have signed up for this tour, that will start. The meeting place will be outside in the lobby area. Otherwise, I wish you all a very good evening, and I hope to see you all back here again tomorrow at 9 o'clock. Thank you very much.